Chills. It's cold down here. Because I couldn't find my own.
Okay, so I'll refresh your memories on what we were working and then continue to work with joins today and just a little bit of queries. Okay, so we'll start today and this will go on for the the rest of the semester. It's all joins and subqueries. Okay, so what we had talked about normalization, we've kind of almost inferred that you will never usually work with a single table in a database. There'll always be more than one tables, because when we start doing normalization, usually we'll have more than one tables, we'll be splitting tables and so on. So our next step is then, if you're not only working with one table with which we've been doing till date, then how do we get our results? Because some of the tables were really odd. Remember how they only had numbers, which were not making sense at all. So then we have to learn how to join tables together so that we can get the result out of joining. So example, I pick up an ID from one table, look for the name in another table, look for the toy ID in that table, get its color from another table, and so on and so forth. So definitely what we need is join. Now join comes in a few flavors. There is an inner join and there is an outer join. And the inner join has an equi-join or a natural join, and an outer join has a left outer join and a right outer join. So I'll kind of introduce you to all this today slowly so that you have it in your head. And then next time onwards, we'll start doing it more easy, in the sense syntax wise we'll go the easy way. Okay, so as I do it, if you have any questions, ask. Otherwise, I'm assuming you know what I'm talking about, right? So this what I've given here is basically 3 tables, I think, if not mistaken. So it is creating a database that stores information about boys and toys, and also the toys that boys own in different related tables. So basically there are 3 pieces of information: information about toys, information about boys, and then information about which boy has which toy, right? So that kind of scenario is what I'm trying to build. After this, we'll stop the boys and toys. Okay, so and then all tables are already in third normal form. So now onwards, whenever I use a table, we'll critique it in 2 ways. One, the field structure and everything, and then secondly, whether it is already in its third normal form. Okay, now again, I've picked up these examples from wherever I could, so I'm ready to critique them like you are, and if there is anything that is amiss, we'll just add it. So please ensure that you always have these 3 set statements, at least this one for these. The strict tables always when you need a not null, and if you're not updating anything, it's the statement on 9 is not required. But these are the 3 set statements we've been working with over the semester. So I kind of just keep them there. So you have your not null, you have your safe updates, and then you have this new one that we've started adding last week. Just to be on the safe side again, maybe all of us by default have this storage engine, because MySQL 5.7 onwards, that is the default engine. But we are not assuming anything. What happens if we want to put it on a server? We have no clue what the server's default storage engine is. So we'll stick to this also. So ensure you have it. Don't assume that that's my settings on my laptop when I mark your assignment. The drop and the create, you've seen it many times now. There is no use here, because what I'm doing is I'm qualifying my table name everywhere. Every table name is qualified. Again, just because I don't do this often, I'm just doing it in this example so that you don't forget. You tend to forget something, and then when the exam comes, it's a blank. I don't want. So I'm just doing it again so that you keep in mind that there is a way of not using the table. The only extra thing you have to do is you'll have to qualify every table in your database. Okay, so you'll see that I'll qualify every table. Every table will have the database name dot the name of the table. That's what I'll do. It's quite wordy, like I have to type a lot, but it's okay. Like it's something that is available. It's something that you may need, so you should know how to use it. Okay, so now this is a simple table. It has 2 fields, a toy ID, which is the primary key. It's not auto increment, it's just a toy ID. And the toy, which is the name of the toy, is a varchar, which is not null. So both fields are not null. I have a primary key. So the table definitely is in first normal form. It has a primary key and all fields are atomic in nature. There are no repeating groups. Is it in second and third normal form? Remember I said by default, If you have a primary key with a single field, it automatically becomes in second and third, because second and third talk about non-key attributes depending on part of the primary key or indirectly on the, but there's nothing here that it's just one field. So how can we talk about parts? And again, since it is a single field and there is nothing else, I just have a toy, I don't see a third field. So there is no non-transitive relation. So this table is in third normal form, right? What I've done here is I've inserted some data into it. Again, if you like, and if it helps you, because you kind of assume that list cannot be given, you can, if you want, you can say toy ID, comma toy if you like. You can do that. Oops, sorry, wrong place. You can mention your list. So you have the option of mentioning the list, remove whatever you don't want, change the sequence, whatever you like, as long as you're following the definition of the table. So I have to have a field. If it is not null, then I have to add something to it. But if it has a default, I'm okay. So you should know about those things, but otherwise a field list can be put irrespective of whether you're giving everything, whether you're giving part of it, any order that you like, everything can be done, right? I don't put it because I always put all values in the same order, but that's not the rule. You can do it in any order you like. So my first table is ready. Let's look at the second table now. The second table is the boys and toys. So before that, I can show you the third table also, and I think I'll need it before it. What's my third table? Color and toy ID and color. And this boy has colors, right? No, they don't. Okay, so that's okay. I'm thinking, do I need the third table to be before this? I don't, because it's not making a reference. So my second table is about, where am I? Have I lost it? No, my second table is about boys. So I'm okay. Again, the same thing. There is a boy ID and a boy name. Same concept. It is in third normal form. The boy ID is a primary key. Both fields are not null. Every field is atomic. It is already in the third normal form. There's nothing, I mean, it's a simple table. And here is the data. So every boy has a name and every boy has a boy ID. We don't talk about boy IDs usually, but every table needs a primary key. So what would you think of a primary key in a table where you're keeping information about boys? Of course, you could have had age and height and weight and so on, but those are not, none of those can act as a primary key. So I kind of stuck to only the boy's name. You could have much more in this table, of course, right? So that's your second table. No big deal. No, two small tables, one information about boys, one information about toys. Now let's look at the third table. The third table says, now I want to keep this information, which boy has which toy, right? So now the table is very odd. Look at the values, 1, 3, 1, 5, 2, 5, whatever, but that's okay. That's how I have to normalize it. Now it only has two fields, a boy ID for the boy and a toy ID for the toy recognition or identification. And both of them together are the primary key. Why? Because a boy can have many toys and a toy can be owned by many boys. So that you can make either one of them only the primary key. So the combination is the primary key. So you won't have 1, 3 again in the table. You've given that information once, that boy number 1 has toy number 3, and that's all you have. Now the foreign key constants that are only implemented in InnoDB, they're not implemented in my ISAB. So therefore we've made our storage engine as InnoDB. What is it saying? It's saying, and I've kind of started putting better names instead of just calling it CFK1 and so on. I've noticed how I've kind of, this is a norm. The name of the table from which you're drawing it and the field name, which is kind of acting as the foreign key. Okay, so I've said the constant is called boy's boy ID. The foreign key is this boy ID, and it is taking its value from the table and the boy ID of the table, right? Keep in mind, these two fields needn't have the same name. They needn't have the same name. The boy ID here could have been called anything. You could have called it TT boy ID, doesn't matter. What is important is this. What is it referencing? It is referencing the boy ID from the other table. That's all you have to know that. That's the information you need. This field is a foreign key. You've already said that this field is a foreign key, right? You've already said that this field is a foreign key. So this is important. What it is called? Is it called different from the original name? Is it called the same? Doesn't matter. Why do we keep it same? Just easy for us, right? It's easy. I mean, I can make a connection, but that connection is not coming by the name being same. The connection is coming by the references. Okay, so keep that in mind. So if you see that they're not the same, you can say, oh, that can be a foreign key. Of course it can be. It can be just any name, really doesn't matter. So the name is not important. The same name being the same name is not important, but these two lines tell me that this is a foreign key and it is drawing its value from the boy ID of the other table. So a foreign key is a field whose value is coming from another field in another table where it is the primary key. That's the definition of a foreign key. Okay, and similarly toy ID, this 11 is not necessary at all, guys. I mean, because I said this is coming from a different source, maybe from the web, this 11 has no meaning at all. All that this 11 has a meaning is in display. When you display this, it is saying, give me 11 places to display. I want to see 11 as a size. This is your output size. That's all. That's all it is saying, nothing else. Right? Because for an int which goes from some number to some number, 11 is the size. And that's what it is saying. You can remove it and then it is no different. And I've never used it because it is a little confusing. What does it mean by saying int 11? Does it mean that it is an integer of size 11? No, it doesn't. Right? Ints are fixed sizes. Right? Ints are fixed sizes. There are how much? 4 bytes or 8 bytes? 4 bytes, I think. 32 bits each. So the 11 doesn't make sense at all. So you can remove it. And you, I mean, if it doesn't confuse you, sure. And look at the contents of this table. I can't make any sense of it. 1 3 1 5 2 5 3 2 4 1 5 4 6 2. But what it is saying is boy with ID 1 has toy with ID 3. Boy with ID 1 has toy with ID 5, and so on and so on. That's what it means. But of course, if I show this table to my client and I say, here, this is which toys are owned by which boys, he'll say, what's that? So therefore, I have to kind of connect it. If I want to know which boy has which toy, I have to connect it with the boy tables also, and I have to connect it with the toys table also, join the 3 tables and show the result. That's why you need to learn how to use joins. And there is a 4th table, which is actually only keeping the color. And this is something that was asked by a student who's not here. He's from the other section, actually. He said, why can I create the color without a color ID? Do you need a 5th table for the color ID? You could create a table like this also. I mean, you don't have to create a color table in which you're keeping all the colors and pick up the color ID, but it is extensible. For me, it is better to create a color table, put the colors and IDs there, and then use the IDs here. Why? Because then if you have to add a color, you have a place where to add it, right? But I kept with this for, just because he had asked the question, it is possible, so I kept it. So what does this have? It has the colors of the toys. You'll say, why didn't we put the color in the toys table? Because remember, that was the repeating group. One toy can occur in more than one colors. That's why we cannot put it in the toys table, because a particular toy can occur in more than one colors. So if it is more than one colors, it is a repeating field. Yellow, green, blue. I can do that. So I have to do this. Okay. So what's coming in this table basically is the toy number, whatever 5 is, and in which color that particular toy is available: white, yellow, and blue. It's available in 3 colors. So I cannot put these 3 colors in one record in my toys table. It will say, oh, that's not in 3rd normal form. It's not even in 1st normal form. What talk about 3rd? Right? So I cannot do it. So what have I done here? Oh, just so that you know, I kind of missed it, but there was nothing here. This is in 3rd normal form, because there is no non-key attribute at all. There are only 2 fields, and both of them are together are the primary key. So it is in the 3rd normal form, because 2nd and 3rd normal form talk about non-key attributes, and there is no non-key attribute in this table. So automatically it is in the 3rd normal form. It definitely is in the 1st, because it has a primary key, and I don't see any repeating groups. Right? Okay, the last table then. Sorry, I had to go back. And the last table then, it has a toy ID, which is coming from the toys table. There it is. It's coming from the toys table, right? And it has a color, which is just a varchar. And again, what is the primary key of this table? The combination together. It just can't be the toy ID. It just can't be the color. Because notice, how can you have 5 5 5 3 times? Toy ID cannot be the primary key. You have the white color twice, or blue or yellow, who knows? But it can be the primary key. But the combination is. And by making the combination the primary key, I won't put repeated data in this table. So is it in the 1st normal form? Definitely, because I have a primary key, right? And I don't see any repeating groups at all. Is it in the 2nd and the 3rd normal form? by default it is, because the only two fields that are present in the table are the primary key. There is no non-key attribute. Because remember, second normal form, every non-key attribute must be fully dependent. When there is no non-key attribute, automatically by default, it is in second normal form. Third normal form says every non-key attribute must be directly dependent. There is no non-key attribute. So it is in the third normal form. So all my tables are in third normal form. So from now on, definitely we'll keep normalization in picture. Every table will be in third normal form. As I said, there are more. There is a 4 and a 5, and there is a BC and F, but we will stop at the third. Of course, when you go out, if you work in this field, keep in mind there is more rules to normalization. And what do? Make the table better in design and in maintenance in future. Okay, I can't discuss them because it will take another 3 hours and I don't have time and it's not in your course. But if you're interested, you can always come and say, Anju, I would like to discuss it, then I'll prepare myself for it. Okay, I haven't done normalization 4, 5 BCNF for a while. I only answer questions if asked. Okay, so that's the table. So this boy 5, sorry, this toy 5, whatever it is available in white. 5 is also available in yellow, and 5 is also available in blue. Right? So now we have 4 tables. So what I've done before I kind of start writing joins, I've shown all the 4 tables. So now I've kind of given up. I've come back to use. I've said use this table and I've said select this. Now I don't have to qualify it. Okay, I don't have to. So this is showing you that it's up to you. If you want to use a use statement, please go ahead. If I don't put a use statement, then you should understand that every table needs to be qualified. Okay, then you have to, when you're answering your queries, you have to qualify every table. Okay. Okay, so this select, if you run this, if everything is okay, let me save this as, so that at least when I pick it up from you, I know. So I'll just remove the blackboard from it. Okay, now let's run it. Wrong place, let's run it. And there are the 4 tables. So that's about toys, right? All toy names with their IDs. That's about boys, all boy names with their IDs. That's about which boy has which toy. Absolutely can't make sense, right? But that's the information. And then which toy is available in which color. Those are the 4 tables that we need to work with. Okay, keep that in mind. You'll say, oh, that's quite tough to keep in mind. Yeah, I know, but there is an easy way. I'll show you what that easy way is. So we'll learn how to now create a ERD, entity relationship diagram, in MySQL. Like you have class diagrams in Java, which kind of, if you have a diagram, you can create a class out of it, and then you can see the relationships and say, oh, this has this one, and so on. You can do the same in relational database. The right way to do is create the diagram first and then create your tables, right? But I already have my database. It may happen that you're getting your database and your tables from another source, but there is no ERD and you would like to create an ERD. So I'll show you how to create an ERD. I'll do a reverse engineer. My database is ready. My tables are ready. I want to see the relationships in a diagrammatic representation. So we'll draw an ERD. They're called EERs in MySQL Workbench. EERs standing for Enhanced Entity Relationship. I don't know what's enhanced about it, but whatever it is, right? So they're called ERDs. Entity is the tables. Relationship, what's the relationship between them? Diagram, because it is a diagram. Okay, so they're called ERDs. The other thing is you start with ERDs and these and IDs like MySQL Workbench. You can give them a diagram and you can say, this is my ERD. Can you create a database and tables for me? That's how you would do it. Okay, so let's try to do this. Now, how do you do it? Please ensure that you have InnoDB set properly. You should have this, otherwise it won't draw it properly. It won't show relationships otherwise. Why? Because relationships, foreign key relationships, are not implemented in my ISAM. So it won't come up. So they should be implemented. So it's this. Now, how do you draw it? Run this script once so that the database is ready and your tables are ready, right? Only then can you draw an ERD. So to run it, just run it. If you have it from me, there are no syntax errors here. What is it saying? So you must have made some mistake. What is it saying? What does the error say? Read your error. What does the error say? But no error. 10 rows are returned from table toys colors. 0 for the third table. What happened to your third table? Okay, let's look at your third table. What did you do? So will all come down? Okay, let's come down. No? That's your second table, the third table. I'm interested in the third table. Now, okay, come down. What are you seeing? You're seeing insert into, okay, you're working on dream mostly. Do you think you have, did you run it once? Oh, remember if you're on Dreamhost, you'll have to drop the tables before you create, just in case. Right? You forgot that. I don't need it because I'm working on my local machine. We drop databases, so we don't have to drop our tables. But if you're working on Dreamhost, then you may have to drop your tables. So put a drop table command. Maybe that's, I don't know, that could be a reason. That's the only thing I can think of. If it is my script, then that's the only thing I can think of. Right? Okay, so let's try to now create an ERD for this. Please go to database. So run your script once so that the database is ready. Okay, go to database and you'll notice there are two. There is a reverse engineer and there will be a forward one also, which is not coming. Oh, it will come in when I create a new one. Okay, click on reverse engineer. You're trying to do a reverse process. Okay, go reverse. It says, okay, what's your connection? So please ensure you're on the right connection. If you're using Dreamhost, then you have the Dreamhost connection. If you're using your local machine, whatever connection. So this should be the correct connection in which you work. Okay, if that's the case, we'll go to next. It says, okay, I've connected to the database. I'm going to retrieve your schema list. That means what databases you have. I'm going to retrieve it. And I've checked the configuration of your server. Everything looks okay. Check means everything is okay. Let's go to the next one. It says, here are your databases. Of which one do you want to draw an ERD? Now, you may not see such a big list. Yes?
It's trying to default to, like, wants it to go to root. Just
no, you'll have to just change it here to your stored connection. Yeah.
Right.
So if it is not your connection that is showing up, if it is not the connection that is showing up, then all you have to do is change it. And you can, oh, now it starts coming. I think once I run the reverse, then the forward comes up. That's strange. But anyway, if that's not the one you want, select the one from here. You have the whole list here. All your connections are here. Okay. Okay, let's go to the next. Let's go to the next. Let's go to the next. And here is the list of databases on my local machine. Right. So you may have your own list. Now, which one did we just create? I think DB Toys it was called, right? So look for DB Toys. Boys and Toys. Okay. The name of the database. Are you sure? Toys and boys. I don't see it. Boys and toys. Oh, B. Oh, B. Okay. There it is. Check it. Say this is the one that I want to work with. Okay. So select your database. Boys and toys. Thanks. I thought it was just boys. Anyway. So select the database with which you want to create the diagram. And this will only appear once you've run the script because, I mean, only then does the database get created and tables in there. And then go to next. It will say, okay, I have retrieved the objects from your schema and I've checked the results. Everything looks okay. Check means everything is okay. And then it will tell you that I have found 4 total objects. Remember we had 4 tables? So it says I have found 4 tables. There could be, it says there could be views, there could be stored procedures, there could be much more. We are only working with tables. And I'll say, okay, execute it. Create a diagram for me. And there it is. So if you kind of bring it forward, now you may see different lines from what I'm seeing. I'll show you why I have different lines. So try to kind of put it so that you can see them together, right? Here are the 4 tables. Let's try to read it. This is your first table and you have a primary key in that table. Indexes means on which indexes are created. You can create more than one index on a table. By default, an index is created on the primary key. What is an index? The English word index, where you check, oh, this record is at this place, this record is at this place, like finding it. Similarly, in all 4, there's nothing else. I haven't created anything. All 4 of them will show primary key. What is listed here? The fields are listed here. Notice boy ID and boy, their types are listed here. So if you wanted to create one yourself, then you would start with a new one. You would go model and add a diagram. You can create your own diagrams. That's how you begin. Designers will first design the diagrams and then you can just kind of say, okay, now create a whole database and for me. Now these lines, if they look different from mine, all I've done is this relationship notation is a different one. Yours could be the crow's foot, which is the default, right? It's the crow's foot. The crow's foot is showing you something. Now let me explain what these relationships are so that it makes sense to you. There are three types of relationships that can exist between two tables. There is a one-to-one relationship. A record in one table only has one partner in the other table. There is a one-to-one relationship. Every student only has one ID. Okay, so if you have a student ID and student name in one table, and you're using a student ID in another table in which you are keeping information just once for a student, these two have a one-to-one relationship between the IDs. That's a one-to-one relationship. Not seen a lot, but it exists. The most seen one is this one. Then comes the one-to-many relationship. What it is saying is that a value in one table occurs once in one table, like toy ID, but can occur many times in the other table, like your boys has toys or the colors, right? So there is a one-to-many relationship. A toy occurs only once in the toys table, but it has many partners in the colors table also, and in the boys has toys table. So this is a one-to-many relationship. Make sense? It only occurs once in one table, and it can occur many times in the other table. That value can occur many times in the other table, not the field, the values. So toy ID 1, or pick up any table that you had. If you notice, we can say which has what. So notice how 5 is occurring 3 times in this table, the toy ID 5, but it only occurs once in this table. So the relationship between this table, this table called toys, and this table is one-to-many relationship. Okay, that's how we say what the relationship is, one-to-many. And then there is many-to-many relationship. You will see them usually in the connecting table. Look at this. The value, I mean, it's not 4 is not occurring many times, but 1 is. This 1 occurs twice here, but it only occurs once in the boy table, right? And the combination, the 2, 1 occurs, no, this is not a many-to-many also, no? This is also one-to-many and one-to-many, no? But many-to-many says there is a relationship which it can occur many times here and many times here. No, it's not in these tables at all. I'll do one with you, then I'll tell you what is that relationship. These tables all have a one-to-many relationship. The relationship between boy, and that's what this diagram is showing you. Now go back to your diagram. What is it showing? It is showing the relationship between boys and the relationship between toys, and has a one-to-many relationship. And the notation are these. You can use this notation, 1 and m on both sides. You can use this notation, 1 to infinity. Infinity means many. Or you can also go 1 to a crow's foot. Like this. That's called a crow's foot, right? So this is what it is showing. This is the diagram that shows a crow's foot. The one I had chosen was a little different. So notice the relationship between this table and this table is one-to-many, right? Do you see? The relationship between toys and this table is one-to-many. And the relationship between this and this is also one-to-many. Now, if you want to look at it a different way, there are a few notations here. There is object notation also. The default is this one. And the simplified will not show you the primary keys. That's all it does. That's the difference between this, right? So you can choose the notation whatever you want. I stick to this because it's fine. It's not a big deal. It's easy. Now here, this was your crow's foot. Try to do the classic. This is the classic. Classic uses diagrams and it says 1 and it kind of shows star for many. So it will put 1 on one side and on the other side it will put 1 and star. And then the one that I chose, I like that because what it also does is it also connects you to columns. So that means it is telling you that this boy ID is connected to this boy ID by a one-to-many relationship. You also see the connection between field. So if the field names were different, I can still see the connection. So it helps me to say, oh, this boy ID here is connected to this boy ID here in one-to-many. So even if the names are different, it doesn't matter. I can see the connection visually. Okay. So always, whenever we'll do assignments or you do assignments or we do classwork or class assignments or exams, always have this table ready because it's very easy to look and answer using the table or using the diagram rather than looking at the tables over and over. All fields are mentioned. Relationships are being shown. Names of fields that are connected are shown. Everything is there. Now, what if you also kind of go a little deeper into the diagram? You see a key has been drawn in front of boy ID. Do you see a yellow key? That tells you it's a primary key. Yellow. Do you see a red key in front of this? It says that it is a foreign key whose value is being drawn from somewhere else. That's what it is saying. So now it's red because it's a foreign key. Each one of them is a foreign key. The combination is the primary key, but they can't color it half-half. So whenever you see red, so both together make the primary key because they have key symbols in front of them. Why are they red? Because they are foreign primary keys. So they are foreigns and primary. Okay. So you see that. Also, you will see these diamonds in front of some. I forget. There is a blue one, and no, it isn't showing here, but sometimes it can be blue and sometimes it can be without color. The color is different. I don't know what does it mean. I forget now. I'll have to look it up. Look up, just Google it. In MySQL Workbench, see what is the use of that rectangular, the diamond symbol. But there are two colors. One is blue, which I see, and one is, it's just saying it is a field, but the color has a significance. I forget. I'm sure one of you will look up and let me know, right? Names of tables are coming at the head. Names or fields are coming. Their types are coming. So it's such an easy diagram that you don't have to keep referring to your tables in your code. So use this diagram when we are doing joins or subqueries or whatever. Okay. How did it go, Amanda? Okay. Okay. Right. So there it is. This is called an ERD. So now this point onwards, I'll start drawing ERDs. But as I said, I'm doing it reverse. I mean, I've created first and then I'm doing it. But what you should actually be doing in the real world, I mean, I cannot say, you can always go the opposite way also. Somebody has given you databases and tables and you want to draw an ERD. But you can always create your own diagrams and it will give you an empty kind of page. And here is everything. Here are the relationships. And notice there is a 2 1-to-1. There is a 1-to-1 here and there is a 1-to-1 here. The difference is a dashed line and a solid line. Now this is therefore they're called enhanced. They do much more. But one says it is a non-identifying relationship and one says identifying. Identifying means one table cannot exist without the other. That's what identifying is. So it is a little complex. It's more advanced than what we need, but that's what identifying and non-identifying means. Notice how you have these symbols. This is your table symbol. So anytime you want to place a new table, drag and drop here. Oops, I'm not very good at it. Oh, okay. Oh, there I have it now. There, right? And then you can start. If you want, you can just start kind of putting values into it. So you can go here and then you can put a field. There should be somewhere where it says here. No, that's a view. Somewhere it should say a field. Place a new image, new text object. No, that's an eraser. Move model. How do you put a field inside it? Or maybe I go right click. And I say edit table, maybe. Yeah, there it is. So as soon as I say edit table, now you can start adding your fields here. So you can give your column name. So what's your column name? So let's say my column name is ID. Come on. Okay, so my column name is ID. Of course, what's your table name? I'll just say table example. I'm just kind of giving you an example, okay? I'm creating a table. So what's my ID? Yes, is it an int? Yes, it is not. If it is not an int, you can change it from here. Okay, and then is it a PK? Is it a primary key? Is it not null? Is it unique? Is it unsigned? It is, I don't know what. Oh, if it is an int, maybe that's for bind. No, blank. B is for blank. B is blank. Okay, and then is it unsigned? Zero fill. I don't know. We haven't used zero fills. AI, automatic increment, auto increment, right? And G, general, because and a default expression. So I don't know what G means. I don't know. What could G be? We haven't done a G that is making sense. What is in G? Yes or no? So a checkbox. So I have to look up. Blank makes sense, but G, I don't know. G, I don't know what G means. The others are okay. When you add a field, then you can go to the next field. And as you do that, it will be added here. Could not set new data type. Why? That's strange. Why can't you set it? Did it come here? No, it didn't. So if I say it's a primary key, it's not null. I can also say it's not auto increment, which I didn't want to, but that's it. And then come here. There is nothing else I see. Do I do a return? Enter? No, that's not it. Anything else that we can see? Anything like an OK or something or add? Anything here? No. Okay, that's not it. Because it's not taking it. I should just go to the next field. Is it okay now? That's strange. Now it just took it. Okay, let's try another one. Let's try and name them. Okay, let's try and name. It's just a field. It's a varchar 45 is okay. It's a primary key, no, not null. Let's say yes, not null. Does it have a default value? No. So it is working, except that why am I not seeing it here? Do I have to do a control S and it will start showing? And when you do a control S, it just saves it, okay? It saves it in an MWB extension. Why is this not showing? Is there a refresh button? See if there is something saying do it or something. What is this one? Data type, storage. Oh, generated. Oh, there it is. G is for generated. Which I don't know. I'm assuming generated means auto increment, to do with auto increment. But why are the fields not showing up here? If I'm done and I come back here, it should show it, right? My table is ready. Let's see if I can, if I drag another table, then it comes. No, the fields should show up here, right? If my table is ready, is there something which says copy, edit, copy? Copy SQL to clipboard is saying generate SQL statements for me, okay? It should show up here. Can I try it and come back and see if it comes? If I say an edit, it goes back here, but it's not showing. This field should come here automatically when I do it. I haven't used the way of forward engineer, but logically it doesn't look as if something is wrong. Can I close this and then they will come up? No. Yeah, why are the names not coming up here?
You have to click the little gray arrow.
Which one?
The arrow.
This one? Oh, okay. Oh, of all the things to do. But where are the fields now? I can't even create a... Oh, I see it here. Yeah, you're right. I see them, but I can't... There it is. Oh, you have to click the arrow to make it appear. Okay, there it is.
Also, the blue diamond
Means not null. And the white one means null is allowed. Okay, thank you. Thank you. So the blue one, we've just found this out. I thought I know there are two, but I don't know what they meant. The blue one says it's a not null field. Okay, so any field that is not null. And then you'll see a white one will also appear when I use it. When you see it, the white one, I'm assuming that means it can be a null value. Like,
there's also a red one.
And the red.
I couldn't find it.
No, okay. At least we know some now. Okay. Okay. So notice here, anywhere you see keys in front of it, it means it's a primary key. The color yellow means it's a primary key, and the color red means it's a primary key, but it is also a foreign key, right? The blue diamond says it is not null. Okay. So we have these. Of course, the table name is there, the field names are there, their sizes are there, their types are there, and the relationships are there, which is very important because that's what we need when we are working with joins. Okay. Okay. And you can do whatever you like. You don't have to draw, you don't have to use this 1 to infinity and join the fields. I just like it because I find it easy, right? That way, when the field names are not the same, at least I can see the connection. Here, the field names are same, boy ID, toy ID, it's making sense to me. But otherwise, if they're not the same, and there is no rule, as I said, that they have to be same, then this helps you. Notice it is exactly connecting toy ID here with the toy ID here, toy ID here with the toy ID here, and toy ID here with the toy ID. Okay, so that tells me the columns that are connected. So I chose the columns one. I chose the column ones, right? You can use whatever you like. There is a UML one also. UML means Unified Modeling Language, the one you use in Java. Okay. I'll stick to the one I like. You can choose whatever you like. Okay, I'll leave it to you. But definitely, let me tell you from experience that if you have an ERD, writing answers to queries is much, much simpler. Very simple, because you can make a connection. If you're doing an assignment, I would even say take a printout and keep it so that you can keep referring to it. Okay. Anyway, so that's your ERD. Okay. Now let's come back to what we were doing. And you can always save an ERD. You can always save an ERD. When you try to close it, it will ask you, do you want to save it? Okay. And you can do that. I'm sure there must be something in file also. Here it is, save model. Save model means save your ERD. That's what it means. It saves in an MWB extension. I don't know. I've never even thought of what that means. But anyway, okay. So let's come back to what we were doing. So my ERD is ready. Anytime I have to come back, I'll open this page. So I'll close this one because this is the one I was creating. And this is just telling you that you're working with the DB toys and boys. And there is another one, which is my DB, which must be whatever it is. You can delete this if you want, or you can export it, or you can delete it. Export as a PDF means you can then print the PDF. Okay. This one I won't close yet because I will be needing it. You can close this one also if you like. Close document, you have to save it. Oh, it says, do you want to save it? So I'll just not do that also. I don't want to save my diagrams. They clutter too much. Too much cluttering goes on. Okay, now let's start answering our queries. So slow and steady to begin with, and we'll become smarter next week as we go on. Now, let's look at the various joins that are available. You may deal with any one of them. You may need an equi-join, you may need a natural join, you may need a Cartesian product, a cross join, or just a regular join. There are so many ways of doing it. So let's start with the first one. The most easy join, or I can also tell it the most useless join, is the one that joins all records of one table with all records of the other, irrespective of any relationship. Like, are the toy IDs same? I don't care. So everybody in the class says hello to everybody else in the class, irrespective of whether you know them or whether you don't know them. So what happens is, if one table has 5 records and the other table has 6 records, 6 into 5, 30 will be the answer of your cross join. That's what it is. That's just a Cartesian product, like in math. Cartesian product. So every record in the first table is joined with every record in the second table. Then it goes to the second, does the same thing. Goes to the third, does the same thing. So if I have 5 in one and 6 in the other, 5 into 6, 30 records in my answer. So this one says form a Cartesian product. It is also called a cross join. It is also called a no join, because I said it's kind of useless because you're just joining, right? Of the toys and the boys table. Okay. So 2 tables I need to join. Definitely join always happens in more than one table. So let's start. We'll say select, normal select. You can put fields if you like. We'll start with the star just so that I can show them to you, right? The names of the table. Now the names of the tables are, just because they're here, it's easy. I won't go to the diagram. One table is called TBL boys. That's my first table. And you say inner join. Let me be sure, because I'm also used to the easy ones, the comma ones, but I won't do the easy ones. Okay, we'll do not the correct ones, just the wordy ones first and then go here. Okay, no, it's cross join. The word is cross join, for cross join. I can do inner join also, I'll show you how, but it has a name. It's called a cross join. Which table do you want to join it with? The boys table. So one is boys and one is toys. Doesn't matter how you write them. You can write them either way. You can write the boys first, the toys second. It's just a cross join. But there will be a difference in how the records come up in your answer. Because if I say boys and toys, the first record of the boys picked up and says hello to all toys. Then the second of boys, hello with all toys. So the sequence is this. If I reverse it, if I say toys with boys, the first toy is picked up and says hello to all boys. The second toy is picked up, says hello to all boys. Really, it's just a matter of sequence. But again, we've always said we don't know what the sequence of records will be. It's unknown. But that's the only difference. How you will see it. But that's all it is. And that's it. That's the cross join. There's no condition at all. It just says everybody says hello to everybody. So try it. So how many? I don't know how many, but we'll know. So execute it. And there it is. 60 records. That means one has 6 and the other has 6, or 60 can come in many ways. 12 and 5 is also 60. But I think there were 6 boys. 1, 2, 3, 4, 5, 6. I remember. There were 6 boys. So 6 into 10, 60. That's your cross join table. Please notice the fields now. Boy ID, boy coming from the boys table. And toy ID and toy coming from the toy table. And notice the sequence, because I have boys cross join toys. The sequence of my columns is columns of boys first and then columns of toys. So notice what is happening. Boy number 1 is connected with toy ID 1. And then, so again, there is no sequence in the records. Then 2 is connected with 1. Then 3 is connected with 1 and 4. And every boy is connected with toy number 1. Then every boy will say hello to toy number 2. Every boy to 3, every boy to 4, and so on. That's a cross join, a normal cross join. Okay. So that's the word that is available, though you can also use the word inner join in it. You can. So if I take the same thing, so that's a cross join. But if I repeat the same thing and just instead of inner cross join, I put inner. That will also work. That will also work. But I'll leave it to cross because it is a cross join. Okay. So now if you don't want to put a star, put the names of fields that you're interested in. That's all. That's how it is different. If you don't, star says all columns of the first and all columns of the second. If you don't want to do them, just put the names. Boy, comma, toy, boy ID, comma, toy ID, whatever sequence you want. However you want them, you can give them alias names. You can do whatever you like. Same concept holds, like the normal select statement. Okay, let's look at the second one. Now it says to find out what toys does each boy have. So I want to find out what toy does Davy have, what toy does Bill have, right? That's what I want to find out. So what toy does each boy have? So I don't want to see IDs. ID 1 has 5, ID 2 has, that doesn't make sense. I want to have names, right? So it says which boy has which toys. So go to your ERR diagram for a minute. Okay, which boy has which toy is coming from which table? This table. Which boy has which toy is coming from this table? But just all that it has is the boy ID and the toy ID. It doesn't have the names. So the boy ID has to extract its name from which table? This one. And the toy ID has to extract its value from which table? So how many tables do I need? 3. So that's your first question. That's the first thing you will do. What fields do I need and what tables are involved? So I need 2 fields, boy's name and toy's name. So boy and toy. And from which 3 tables do I have to combine? This, this, and this. Okay, makes sense? So that's why ER diagrams are useful. Not necessary, but useful. Okay, so now let's start writing it. So I want to select. I know there is the name of the boy is in the boy field. The name of the toy is in the toy field. Okay, now the tables. I'm showing you inner join. I'm talking about inner joins right now. So I've looked at the cross join, which is an inner join with no conditions at all. Get an inner join with a condition. There will be a condition. And what is that condition? How should you be combining? Think about it. If I pick up a boy ID from here, I want to combine it with a boy ID here whose values are same. Boy ID should match. It should be equal, right? And when I pick up a toy ID from here and try to find its name from the toys table, the toy ID should match. So this is called an equi-join because you're joining on equality of values. When it is something else greater than, less than, not equal to, then it is not called an equi-join. But this is called an equi-join because your conditions are working on equality. Okay, that's why it's called an equi-join, as you see in the comments. Okay, let's come back. Okay, so now which 3 tables we said we are interested in? We said TBL boys is one table, TBL toys is another table, and TBL boys have toys is another table. Those are the 3 tables you're interested in. Now, I keep forgetting that I shouldn't do this to start with. Inner join 1. So now you know that you can replace it with the comma, okay? Inner join 2. But to begin with, we won't because you should know what it means. There, that's how you join 3 tables. You use inner join. So this inner join, this inner join. Sequence doesn't matter. What happens is a Cartesian product or a cross product of all 3 tables is created, and then only those records are picked up. Where? What's the condition now? The condition is the boy ID in the first table should be equal to boy ID in the other table. So the boy ID that is coming from the boys table, you'll have to start qualifying it now because there are 2 boy IDs. There is a boy ID in this table also, and there is a boy ID in the other table also. So sometimes naming fields the same becomes more work, but there are 2 boy IDs. There is a boy ID in the boys table also, and there is a boy ID in the other table also. So you'll have to qualify them. Anytime there is ambiguity, ambiguity means confusion, you have to qualify it. Otherwise, now here there was no confusion. There is only 1 boy field in all 3 tables. If you look at the 3 tables, there is only 1 boy field. There is no confusion at all. The toy is only present in 1 table, not in any other table. But here there is a confusion. If I don't qualify it, all I say is boy ID is equal to boy ID. What does it mean? Nothing. Like your Java, if you don't say this ID gets ID and you simply say ID gets ID, what does it do? It says, okay, work with the local variable. But here it doesn't even say, it says which boy ID. Like you have to tell me which. So what have I said? The boy ID in the table boys should be equal to the boy's ID in the other table. And I'm not yet done. There are two conditions, right? And what is the other condition? The TBL boy toys, its toy ID should be equal to the other table dot toy ID. It's just putting it in a query if you understand what you're doing. So I said I need 3 tables. The 3 tables have come in from. I said the condition should be the boy IDs should match. I've given that condition. And toy IDs should match. I've given that condition. But of course, if you don't know what the conditions are, how will you write them? So understanding them is important. And it will work. You will see the boy's name and you will see the toy's name. And all you have to do is to say if this is right, you can match it with this table, the 1, 5, 1, so on, so on. So this was the boys table, and which boys has which toys. How many do I have? 1, 2, 3, 4, 5, 6, and 7. I have 7 records, right? So I should see 7 records in my answer, except 1 will be replaced by the name of the boy and 3 will be replaced by the name of the toy. That's what we are doing, right? So 7 records in my answer is what I'm expecting. This is an example of an equi-join. Why? Because you're joining your tables on equality, right? Now, just so that you know, you can also, I'll put it in a different line, you can replace this word with on also. Actually, on is used more than where, because where can also, on says what is the condition on which you're joining the tables. Whereas where is what records to need to select. You may need on and where, both of them. So I'll stick with on, but you can have where here. Right? So on says on what condition. Sometimes you need the on also and sometimes where also. And then you have to just, you can't write where twice. So you'll do it. I'll show you. Right? The same query, just because I had written it, can also be written as this way. Because I had written it, I'll give it to you right away. You can replace the word inner join with commas. And that's what we will do in the long run, because we don't want to keep writing the word inner join. But it can be done. But then you cannot use on. You have to then use where. You cannot use on. So that's the difference. When you use commas, you have to use where. When you use the word inner join, you can replace on by where. You can use either. And of course, they will both run. So this is an example of an equi-join. So 7 answers, because I know the connecting table has 7 of them. And 1, 2, 3, 4, 5, 6, 7. Right? You can order it if you like. You can order it by name. Nothing stops you. You can do whatever you've done in a select statement. And of course, the same answers here. And you can double check. So Davy has 2 toy soldiers and baseball board cards. Sorry. So let's go to whoever Davy is. So Davy is boy number, of course, 1. And toy soldiers is 3. And what was the other one? I think cards, 5. 1 and 5. 1 and 5 and 1 and 3. There they are. 1 and 5 and 1 and 3. That's Davy. Right? So the answer is right. So that's an example of an equi-join. Why is it called an equi-join? Because the conditions are equality. Okay? That's an example of an equi-join. You can use on, you can use where, but where says you only can use commas. You can't use the word. And in the long run, you will start using commas anyway because it's easier. But situations may arise where you need the on and the where, and then you have to use the word inner join. Okay? And I'll show you some example for sure. Okay, anything else that I need to extra tell you in this one? I'm not so... No. Okay, let's go ahead. Let's use a natural join now, another inner join. So you've seen a inner join, which is a cross join. You've seen an inner join, which is an equi-join. Now I'm seeing a natural join. Now, an advantage in natural join is this. The use of the natural join is that fields with the same name, right? So that's important, the name. The same name fields are automatically compared for equality. I'll show you what I mean in a minute. I'm doing the same question, but with now natural join. So I'm going to write it. I'm going to copy it. I'm going to replace the word inner join with natural join, and I don't need the conditions. What will it automatically do is it will look at the three tables. It will look at the fields that have the same name, and it will join them on equality. So there is an advantage of giving same names if you want to do a natural join. But again, the disadvantage could be you named two fields same, but they're not even related, which you will not usually do, but it can happen. So natural join will automatically pick up boy ID from the boys table and boy ID from the connecting table, join them on equality. And it will pick up the toy ID from the toy table and the toy ID from the connecting table and join them on equality. This is exactly a replacement of this, exact replacement. The condition, the equality condition is automatically done. Because instead of the word inner join, you have used the word natural join. So it says do it naturally. That's why it's called a natural join. So it's handy, right? It's handy. Your field names are the same. You want to do it in equality. Why write a where condition or a on condition? So it's handy. But the field names should be same.
What's the difference between them, other than the fact that you need to use the same name?
Nothing.
They
Answer is
do
same.
the
Same thing. Absolutely the same thing. They will do the same thing. If I run this, I exactly will have the same answer. So what's the advantage? Less coding. I don't have to put the where condition. But many programmers don't prefer it because they want to see their conditions and write them themselves. So it's up to you. So from a student point of view, from an exam point of view, from an assignment point of view, you must know. If I say use a natural join, you should know how to use it. If I say use an inner join, you should know how to use it. Right? So I'm not giving you everything. If asked, sure. If not asked, entirely up to you. Okay, entirely up to you. Whatever you like. You like commas, use commas. You like inner join, you use inner join word. You like natural join, join it. Whatever you like. As long as the question specifically doesn't ask you, it's your choice. Okay, but again, in an exam or in an assignment, I'll always ask you something to test you. Okay, so that's your joins. That's your inner joins. Inner join, equi, inner join, cross, natural join, special inner join. Okay, but the conditions are not limited to equality. You could be checking anything. Here I cannot because it doesn't make sense, but I could be checking two records. Maybe the one has, the price is more than the other. So I can say where price in my first table is less than or more than or greater, whatever, not equal to, whatever. You can do any conditions, normal, any condition. And you can do an order by, nothing stops you. It's just order. You can do an order by. So whatever you've learned till now still stays. You can order by a boy's name if you like. It will give you, now what do we have? We have Davies, Beavers, Richie, and Johnny. They're of course not in order. Now they'll come in order. So all that you've learned, so notice Beaver and Billy, Bobby, Davy, Johnny, and whatever, they're now in order. So whatever you've learned till date, order and grouping and having will all work. They all work. All we are trying to now do is instead of working with one table, we are working with multiple tables. That's all we are doing. So the select statement, all features of the select statement will still hold. Anything that you've done, inbuilt functions, alias names, the fields you want, having, groupings, everything, order by, limit, everything works. Okay. Okay. So I just added the order by here so that you could see it, though now it doesn't match it, but anyway, a boy has, and then you can say order the result. So change the comment just so that you know why I like. But otherwise, it's no different from an inner join with equality conditions on the same, on the same named fields. Names have to be same. Or it will automatically pick up the fields with the same name, and it will automatically do the equality for you by default. That's what it does by default. Okay, that's why I've said that fields, the fields with the same, not instead of that. Let's say the fields with the same name are automatically compared for equality for join. So it is an inner join. Okay. So you can say an inner join in which the fields with the same name are automatically compared for equality. It will just do it. So it is the same as above. Okay, it's absolutely the same as above. It's the same thing. Now let's look at a little outer join. So inner join is done. Equi, natural, and cross, okay, with comma, with the word inner join, with the word natural join. Now let's look at the second kind of join. A little dicey, but as if it's not as if you can do it. Let me show you what it is. Why is it called a left outer join and right outer join? And how does it work? And where will it come handy? Where should I use an inner join? Where should I use an outer join? Sometimes you may have an answer by both, but then you have to think which is more efficient and then use that. Sometimes you may not even be able to find an answer with outer join. You may not, it may not happen. You may not have a solution, but sometimes you may, and then you have to think which is more efficient. And that only comes with practice and more experience, right? I just know about it because I've done it many times. Okay, now what is a left outer join? Let me first show it to you and then we'll work. Then we'll answer the question. Use a left outer join to find which toys are not owned by anybody. So that means I have some toys and those are not owned by anybody at all. There is no connecting boy to that toy is what I'm looking for. Okay. So now the two tables that are, where are the toys coming from? The toys table. Which toys are owned by which boys? The table have toys. So these are the two tables I'm interested in. But now I'm not interested in just a join. I'm saying which toys are not owned by anybody. So look at the diagram for a minute. So here is the information of all the toys. Okay. Now, if I want to find out what toys are owned, the information is here. But what about not? I don't have that information anywhere, but I still have this. So I have information about all the toys. Then I have toys owned by somebody. If I subtract the two, take the difference of the two, I have what's not owned by anybody. Right? You see what I mean? I have information about all toys, toy 1 to 10. Then in another table, I have information about which is owned. So toy 1 is owned, toy 3 is owned, toy 5 is owned. So 1, 3, and 5 are owned by somebody. The rest are not owned by anybody. So I still need the two tables, but I can do an inner join because the inner join tells me what is available. What I want is what is not available. Right? So I have to use a left outer join. So think about always, when do you use a left outer join? When you're trying to say if it is in one table, but not in the other table. Like a minus, like a difference, like an except. Okay. So the two tables, so we'll first go step by step. Okay. I won't do the answer first, but I'll show you first a left outer join. So I'm going to select, I'm going to do a star, right? From the two tables. I know the two tables for sure. So a table toys. And I'm just going to write the word left, or is it called left outer join or outer left join? I think left outer join. We'll know for a minute. The sequence I can't remember, but it will tell me if I have a syntax error. Left outer join. Looks okay. Okay, what is the second table? The other one was called TBL, boys have toys. Let me put a semicolon and see. Okay, so this doesn't like it. Because I haven't given a condition, but it's not. So the sequence is right. It's left outer join, not outer left join. Okay. Now it's not yet complete. Even if this, I'm putting this, it's saying there is something wrong. It's saying there is something wrong. And come on, show me the error. Doesn't say anything. Something here. Unexpected end of input. That's all it helps. What it is expecting is the condition. That's what it is expecting. Okay. So now, how do you want to create this join? So again, an on or aware, both will do. Okay. So what's your condition? The toy ID, how are you? You still have to give a joining condition. You have to. In an outer join, you always have to give a condition. In inner, you don't give a condition, it becomes a cross join. But in an outer, it needs a condition. So all I'm saying is, what is my condition? My condition is that the toy ID of this table, I mean, the condition, the joining still remains the same, but the answer is different and should be equal to the joining of this. So the joining condition simply says, how do I join the two tables? Okay, but I want to show you something. What happens? How is this? It doesn't look any different from an inner join. Only what is different is the word left outer join. That's what is different. Otherwise, it's just an inner join. But see what will happen. Please see what is happening in this table. Once you see the output, then I'll explain it to you. Okay, let's run it. Unknown column. Oh, because I didn't complete it. Where unknown column. Some error messages are easy to follow. Okay, now let's look at the example. Let's look at the result. What has it tried to do? Think of what it has tried to do. This is what it has tried to do. It is saying, and the table is important, the table on the left was the toys table. So it picks up one record from this table and tries to find a partner here. Picks up the second from this table and tries to find a partner here. Right? Now see what happens. It picked up toy ID 1 from the first table and tried to find a partner in the other table. It found a partner, 4-1. Toy IDs match, 4-1. It picked up 2 from this table and it said, oh, I have a partner here. I have another partner. That's okay. I have another partner. So it's looking for all its partners. And what are you looking? What is it being partnered on? The toy ID, right? 3 found a partner. 4 found a partner. 5 found a partner. And 5 found 2 partners actually, because 2 boys have 5. 6 did not find a partner. What happened to the other fields from the other table? Both fields were null. I couldn't find a partner. 7 said I couldn't find a partner. 8 said I couldn't find a partner. So did 9 and so did 12. Now, if I want to pick up these records that didn't find a partner, I can say pick up those records in which these fields are null. I couldn't find a partner. And on the other hand, if I say which toys are owned by somebody, I'll say pick up this one that are not null. So see, you can answer this. You had answered a previous query using an inner join where you were saying which toys are owned by which boys. Now you can answer it using a left outer join also. But from the left outer join result, you have to pick up those records that have found a partner. We'll say these are owned. And where you say these are not owned, you have to pick up those records where the fields are null. All fields of the second table will be null. So pick up any. You can pick up the boy ID is null or toy ID is null. So to complete it. So is it making sense now? What am I doing? The left outer join, the word left is important, is picking up every record from the left table and trying to find a partner in the table on the right. If it finds a partner, it joins it. If it doesn't find a partner, puts null in those fields. It says I couldn't find a partner. So if I don't find a partner, I'll put null on those fields. On the second, I couldn't find. So it's just null, null, null. That's what it does. Now, so this left table is being compared with the right table, not vice versa. It's the left table that is the master, and it is trying to find a partner in the right table. Okay, this is important. Putting it on left and right is important. I'll show you it will not work in the other way. Not work means it will give a different result. So let's try to do it just to show you. So here is the first answer. And I'm going to take the same thing now. Just copy it to show you, and I'll kind of interchange my tables. I'll put this on the left and I'll put this on the right. Looks the same, is not the same. There is a difference. The table on the left in the first one is table toys. The table on the left for the second one is table boys have toys. And the two answers will be different. Let's run the same 2 queries together. That's your first table. What did it do? It said, oh, okay, I want to pick up one record from the toy table and find its partner in the other table. And this has how many records? 12 records. Look at the second one. It's the opposite. It says, I'm going to pick up a record from the boys have toys table and try to find a partner in the toys. It will always find it. Why? Because the toy ID is coming from that table. And it only has 7 records. Why? Because the first table, boys have toys, only has 7 records. So there is a difference. A left outer join is trying to combine every record in the left table, trying to find a partner in the right table. It may have no partners, then you will see null. It may have more than one partners, then you will just see more than one partners. 1 with 1, 2 with 2, 2 again with 2. 3 with 3, 4 with 4, 5 with 5, and 5 again with 5. Any partners, all partners. So there is a difference. You have to be very careful when you use left and right outer joins. Okay? Inner join, it doesn't matter how you write the table. So that's not my solution. That's not what I want. Now, I only want to pick up those records that don't have a partner. That means they are not owned by anybody. Put a where condition. See, here is where on will be handy. I can't put where twice. So I have to use on with my combination, and then where is the condition now? So on is like a where you're trying to combine tables. That's the condition. You use on. You can use where, but now I need a where also. So this is somewhere where I can't have two wheres. Then you need a where. So where is the condition? Which records do you want to pick up? Where it is null in the rest. Now the rest has many fields. It could have many fields. Pick up whatever. I am picking up the toy ID field because it seems more natural. Why natural? Because we are talking about toys. There. Oops. And there. Make sense? So combine the two tables, join the two tables using a left outer join. The joining condition is this. This is the joining condition. Okay. I could have used where here, but I cannot. See, I could have. If I just write this one, I'll show you. Both are syntactically both are allowed. You can use where here if you want. Oops, sorry. So on is of course right, but where will also do if I'm not mistaken. Let's see to be sure. Oh, no, it doesn't like it all. Outer joins don't like where at all. Sorry, they don't like it. It's not working. So we are okay. Anyway, but here is an example where an on and where both exist. So you can kind of relate it to inner join at least, that in inner join you may need to use on and where. But it doesn't even allow where. So we are okay. So good. Now I know it. I thought we could do it in outer joins. You can do it. The only syntax allowed is on. You can do where. So here, if you want to make a note for yourself, just because I was confused, because I thought it is, cannot use where. So that way you won't make that mistake. Inner join can do it, outer join cannot. So now what have I said? I said pick up those records, kind of match it with this table. So this is the result of the table, right? This was the result of this select clause. This table was the result of this clause. And then you're saying only pick up those records in which the toy ID is null. I could have used boy ID also. You can use boy ID, nothing stops you. It's any field, you can use any field. If you say boy ID makes more sense to me, boy ID is null, oh, there is no boy, sure. It's no different. It's not different at all. You can pick up whatever field you like and say it is null. So which records will it pick up? It will pick up all these records, 6, 7, 8, 9, and 12. Because they have a null here and they don't have a matching partner. These are the toys that are not owned by anybody. So now run it. There's your answer. Right now you'll say, oh, I don't want to see these null values. Remove your select star and put what there? Put toy ID and toy. That's all. I don't want to see the fields which have null values. Change them to toy ID and toy. Because you don't want to see fields that have null values in them. Or if it only says use to which toys, I don't even need the toy ID. It's only asking for the toy name. There it is. You don't even need it. So the star was to show you how the fields were coming. The left outer join showed you what were the records. Then I did a where condition to say only pick up those that have null. And then now I realize I don't need those fields. So I go back to select toy. So we know the answer should be Tinker Toys, Etch-a-Sketch, Slinky, Kite, and Yo-Yo. So now if you run it, there it is. Answer is right. Okay, makes sense? That's a left outer join. So when will you use it? I mean, you can use it in place of an inner join also, but when do I use it? Usually when you're trying to find something in a table that is not in the other table. Like a difference. But I told you, you could answer it. You could use the same thing in answering an inner join also. You will pick up those records that are not null. Here you are picking up the records which are null. Where they match, it's not null. Where they do not match, it is a null. So you can replace an inner join with a left outer join. Error? What is it saying? It's showing you an error? What does it say? MBO. It's showing you an error because, okay, you tell me why is it showing an error. Yeah, it will, now that you mention it. Okay, what will be the error? Did you read the error? The error said there is ambiguity. Do you know the meaning of ambiguity? Confusion. What is the confusion? The toy ID is also in the toy table and the toy ID is also in the boy have toys table. So which one do you want to pick up? You want to pick up the one in this table. Good. Thanks for bringing it up. But I mean, I didn't think of it when I was writing it. But of course, whenever I would have run it, that's here. There. That's what ambiguity means. Toy ID is a field in the toys table also, and toy ID is a field in the other table also. So it says which toy ID should be null. Tell me. So now that you know, you can do it, and I'll also write it the other way. But you know, that's what ambiguity means. So you can use, if you like, you can only say boy ID. Now, boy ID has no ambiguity. Why? The boy ID is only present in which table? In the second table. There is no boy ID in the toys table. So there is no ambiguity. So if you want to still always qualify it, it's up to you. But if you don't have to, then I'm not asking you. You could have qualified boy ID. You could have qualified it. You could have said table boys have toys boy ID. You could have done it, but it is not required because there is no ambiguity. But definitely when there is ambiguity, it will give you an error.
I'm still getting
Still getting an error? What does it say? Read your error.
both ways.
Both ways.
Ambiguity. That's where the-
Column toy ID in field is ambiguous. Oh, because you're using toy ID here also and you haven't qualified it. It's saying in the field list. I've removed my toy ID from here, but if you have to use toy ID here, you'll have to again qualify it.
So what I'm just looking for.
I'm just looking for the name. Here, Amanda has something else, and I must tell you that something else also. If you have toy ID here, remember now if I run it, it will still say ambiguous. Why? Which is this toy ID are you talking about? Are you talking about the toy ID from the toys table? Are you talking about the toy IDs from the other table? So anytime you use a field that is not qualified and it should be, you'll see that error of saying, oh, it is ambiguous. And it is ambiguous. Which toy ID? So I removed it, so I wasn't getting that error. Amanda still had it, so she was getting that error. But that's all it means. It's not clear. Okay, and both of them should give you the same answer. Same answer. I'll do just the last one and then I'll give you a break. The only difference between 4 and 5 is it says give me the same answer now, but use a right outer join. So this is all you do in a right outer join. A right outer join is different from a left outer join. Oops, Control Z. There. The only difference is the sequence of the table of the tables. So when you use right, it compares the right table with the left table. The right one becomes the master table, right? So definitely, if right is the master table, this should go on the right to get the right answer, and this should go on the left. So you just have to be careful again. There, that's a right outer join. What did I do? I replaced left outer join by right outer join, and I flipped the table names. So it's the same thing. That's what I want. The toys table to be compared with boy have toys, not the other vice versa. So whether you use left or you use right, see that they are in the right position. Otherwise, you'll have a different answer. So the same query now, instead of using a left outer join, I've used a right outer join. I don't know why they created two of them, but the difference is now the sequence of the table names. The table that you want to make the master one, the one that needs to be compared, goes on the right, and it is compared with the table on the left. In the left outer join, the table on the left is compared to the table on the right. That's the only difference between left and right. There is no other difference. You will still have the same answer. So what did I do? I copied the same query. All I did was flipped my table positions. Oh, where is it? There it is. Same answer. Right? So that's an introduction to inner joins and outer joins. Just introduction. Then we'll do more and more and more. Self-join is something else I'll do before I start doing examples. So the aim, as I said, for the rest of the 10, 11, 12, and 13 weeks is joins and subqueries. Okay, two major topics to be covered, joins and subqueries. There is views also, but I usually don't do it, but I can. It just takes 15 minutes. View is just saying some records of a table. So you can kind of just create a temporary view of it. So you don't want to look at the others, you create a view. If I get time, I'll do it. For me, joins and subqueries are more important. You'll see views again. Okay, so I'll do that. I mean, it's not a big thing. I do it just so that I cover my course contents. But this is what my aim is for the next 4 weeks. Okay, so we'll come back, take a break. We'll come back and then we'll do more and more examples. So one more self-join and then more and more examples. Okay. Yep.
Asking me a lot of questions. We only did one cause.
What does it say?
Can't remember. What's the difference? What are the pros and cons? CSS over
You have qualified them or started using
JavaScript
the
has
use?
more control,
Go before
whereas
select.
JavaScript can, or CSS can randomly affect other elements. And you also have to deal with inheritance. with CSS.
Is it running?
Whereas
Does it show in the
JavaScript.
table? Yeah, so it is, that's why you don't have answer. Why?
Design and development instead of programmers. And explain that, like, he didn't even know, even though ours said. Of course, I was saying, you're programming, you're really trying to focus on that.
You haven't changed anything in mind,
But he had a lot of questions with CSS. Stuff, like, programs I never even heard of, I forget what it's called, like, I think on the CSS table.
this is running, third one, right, this one.
I didn't know.
Yeah, because
And that's,
I don't know.
so I know, but I get it, I don't even care because it's not paid, I went for the experience, but the questions he asked, it's like, no, they definitely need to hire web development people, like, not somebody in computer where I only get
Well,
to paid
at
stuff.
least now you know that, now with those questions, you know what you need to look up.
Yeah, but now I'm over, like, I was like, so embarrassed, I felt like maybe I shouldn't have, but it's also like, what kind of projects are you working on? Or you haven't looked into these things, so it's just like, it just pissed me off, kind of, it's like, you think I'm just 19 and have all this free time, like.
Those tables are being created in it. This one you're
It's a
selecting.
job, like, I'm
It's
just
select
trying
for
to hurry through, I have so much homework.
Clear this,
No
no,
time
not
to
use,
leisure
just
around
wait,
and
I
play
will
around,
say
but I
select.
don't.
Clear this. Now let's run from now. I want-
Exactly, but just kind of.
Have munchies. So
310 line. Yeah, from here up to here.
Not feeling good.
What is faster? Which is faster?
I don't know.
Yeah, so errors. Okay, let's go up, read the errors. Start from the beginning. Drop table if exists. Cannot delete or update a parent row from a parent. Oh, I see. This is what it is. See, it is saying the top, the table boys and top is referencing to boys table. But you said if exists. That's what is getting the problem. That's exactly what is getting the problem. You cannot delete a parent row or foreign key constraint tables. Have to do more settings. See what's happening is this. I'll explain what's happening. Come on. No, no. This table, boys have toys, has a toy ID and a boy ID. That means it is referring to this table. But what you're doing is you're dropping it. You're saying drop table if it exists. So when it tries to drop it, it says, oh, somebody else is dependent on it. So I'm doing it. That's what it means by saying cannot delete or update a parent to a foreign key. Yeah, you cannot drop it. No, not this one. The one that is, it is referring. So how will you do that? So this table is referring to boys also, and that table is referring to toys also.
Yeah.
You can't draw any of it. Yeah, you can. Now, that means something other setting has to be done. Then it will say the same thing. Okay, here it says create. So see, when you run it again. this will not-
Remember last time it sent you.
Yeah. Yeah, because of this. You see what is happening? This table is referring to this table. So you can drop it. But if you want to drop it, then Dreamhost doesn't allow you to create it again. So you'll have to do for a condition. You'll have to add some more set statements or something. Like we did save updates. Okay, come maybe I can. In scope up where you put your set statements. That's yeah, here. Instead of updates, let's also add another one, set SQL save deletes is equal to 0. But I'm not sure, I'm just trying, but that's what it is saying. So keep that and put it delete source. Because it says I can delete it in sequence. If it is such a set statement, otherwise we have to put it. Deletes S. Let's try it. Let's run the script again. I mean, run the whole thing. We will clear this. Otherwise, you have to put, yeah, no, same drop. Yeah, and drop it. So somewhere you have to say, I'm allowed to drop. Now, this is something that is only appearing because we're working on the.
I think there was one guy who was working on.
Yeah, he's not here today. Ryan is not here. So you'll have to make some set statement on tables to tell it that it's okay to delete a table, to drop a table, even if there are other tables. See, you ran it once, the table got created. Second table got created. It was referring to this table. Now, when you run it again, it says I can drop.
Yeah.
I have children.
I got some.
Yeah. Yeah. But now the main thing is how. So you'll have to Google. You have to Google and find the answer. I will, right, we'll have to drop. I'll have to look, not right now because I'm in class, but I can. Because we'll have to.
Wednesday, I think.
No, I look at it after class. That's not a big deal. But what do we want to do? We want to drop a table without, it's not, we will get a solution. We just have to test it. So the safer, so something like set, dropping of tables is allowed
Yeah.
if it has children tables, is what we'll have to do. Okay? No problem.
मैंने कहा मैं कहने से भी आज बेटा प्रोग्राम भी किसी ने वाला नहीं ना वो भी लगा करता है मैं
Because it is boring. Monotonous. But he said he's been doing, he only did me when he was younger. And he's been, it's all coding, he knows multiple languages. It shows you how well he knows the material, because he hasn't done the actual mainframe stuff for eons.
wow. What?
There's a storm.
Wow. There's people actually do it. So, will we still have some of this product red here?
No, no,
Or should
your
just all-
product will be right because we are only testing the stock manager class, right?
Okay.
Yeah, you're good.
Okay.
No problem. Okay, ready for the next? Okay, so now what I've given you, you have two clowns classes, clowns.sql from me. Are we on time? 12:40 was okay, right? We went 12:20. 3 students are missing. Okay, open them up at least. So open up both clowns. I want to explain something to you. So if you have that zipped file, it has 1, 2, 3, 4, 5, 6, 7. I think 7 files. The zipped files, if you've unzipped it, open the clowns one which says clowns BB for Blackboard, and then the other one which says clowns with InnoDB. Okay, let's look at it. Now here I'm going to, picked up this example because I wanted to show you an example of a self-join. Self-join means when a table joins itself, right? So you need two instances of the same table. That's called a self-join. Till now, what you've done till now, you were joining tables that were different entities. But it can happen that, and I'll give you a funny example here, but that's the only one I got. So this is an example that basically joins a table with itself. So let's look at the table. So this table, I have just a DB clowns. Okay, it doesn't look like I've followed my conventions very well here. But if you like, you can make those changes, though this one is. So I've opened up the without one, not the with DB, okay? So here is a database that has some clown information in it. So it's information about clowns, right? And please notice, I have deliberately made my engine as my ISAM in my table. So you can either set the engine in your set command, like I have done in the previous script, which I will follow, or you can also set the storage engines in your table create commands. That way it gives you the liberty or the flexibility of making some tables ISAM, some tables InnoDB, and so on. Because each of these storage engine has its own advantages and disadvantages. Someone is good in one, someone is good in the other. But now they've kind of made it, maybe after thinking about it or whatever and research and whatever, they've said that the InnoDB will be the default. So they're assuming that InnoDB is the best engine that you can work with. It has the most flexibility. So that's why they have done it. Before that, it was my ISAM. But anyway, having said that, so you can set the storage engine of in your script at the beginning, then it holds for all the tables. You can also set them using the create command, then it only holds for that particular table. Remember, storage has to do with tables, therefore it goes in the create table command. Okay. Now, so I have deliberately for this script made it my ISAM. I want to show you something, the disadvantage of my ISAM. And here is a table, kind of odd, but look what it is. The table has 3 fields. There is a clown ID in the table, right? There is the clown's name, and then there is a boss ID. So it basically says who is the boss of a clown, who himself, of course, is a clown, right? So therefore, the self-referencing table. So look at its definition. It says the foreign key is boss ID. I didn't bother to give a name to this constraint. I am saying that boss ID is a foreign key and it is referencing the clown ID. So you notice how the referential is self-referential, right? So it's a table. There is nothing wrong in the table. It could exist and it does exist, like it's logical information, and I'll show you what the logical information is. So here is the table. It says clown number 1, because it is an auto increment key, I didn't put it. Clown number 1 is called LC, and his and his boss is 3, which is Snuggles. Because Snuggles will be 3, right? So if you go 1, 2, 3, 4, Snuggles will be 3. And then Pickles has a clown ID of 2, and his boss is 5, and 5 is 1, 2, 3, 4, 5. Clarabelle. That's how you're reading it, right? So every clown has an ID, has a name, and has a boss ID, and the boss is again a clown, so he'll have a clown ID somewhere. So the 1, 2s were not put by me because it was an auto increment key. Okay, so now let's go back. So now hopefully you'll understand what the 3 fields are. So the clown ID is the ID of the clown, is the primary key of the table. It is an auto increment field. Then comes the clown name, which is the name of the clown. And then comes the boss ID, which is the ID of the boss of the clown, who himself or herself is also a clown. So he will be somewhere in the table again. Okay. Now my question to you is 1. So there is a foreign key constraint here. So that means when I add the records, all of these should be referencing to somebody who already is in the table. Like he should be in the, or she should be in the table. So how many do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. But 11 Bobo is referring to a person 12, and 12 is not in the key. Is not a clown, is not a valid clown. So if I run this script, I should get an error because I've said boss ID is referencing a clown ID. I should get an error. A foreign key constraint has been violated. But if I run it, if I run it, it runs. And the table comes up. This is what I was saying, that foreign keys are not supported in ISAM. Therefore, we are going with InnoDB. Okay, therefore we are going. So this was a small example in which I could show it quickly. So I created this for you because I'm now going to use it with Inno, but this is, so it doesn't. You'll say, so the whole purpose is lost, right? I mean, if you can't enforce a rule, then the rule is useless. So this is one example where you will not use ISAM engine. So if you're going to create foreign keys, then you cannot use ISAM engine. You have to use InnoDB. So that's one disadvantage that you're seeing for sure. Okay. Now the other one. So this was just to show you. So this script was just given to show you that an ISAM table does not enforce the self-referential constraint. It does not. So what I've done is I've created it. So this script will work. This should not work, but it will work. So this record will be added. Though the boss ID is invalid. Is invalid or does not exist, you could say. And I had said that boss ID must refer to a clown ID. And here I have something that is just working. And therefore you cannot use my ISAM storage engine with wherever you're using foreign keys. And because we'll be using it at many places, like now that we start doing it, it's everywhere. This is not the right engine for us. Okay, so therefore I have made my engine as InnoDB. Keep that in mind. This is one disadvantage. There are more. There are more. If you read about it, there are more. But this is the one that definitely we can't work without. Okay, the rest are more to do with programming, locking of a table, locking of a row when you do stuff and all that. But this we can't work without. So now come to the InnoDB. So now in this one, same thing. In this one, all I've done is I've said my engine is InnoDB. And the rule will be enforced. But there is a way you have to insert the records. So with InnoDB, the rule will be enforced, but records need to be inserted in a certain order. Now, what is that order? I'll explain it to you. Right? So I had to kind of change the data. But this is what you have to do. If the boss ID is referring to a number like 1, then it must already exist. There must be a clown with ID 1 already. So 1 can only call 1. You know what I mean? Clown number 1 the boss of clown number 1 can be he or she himself. For 2, this is clown number 2. Clown number 2's boss can either be 1 because 1 already exists, or it can also be 2 because 2 is also existing. So the sequence is important. What about 3? Snuggles' boss is 1 is okay. Hobo's boss is 1 is okay. Clarabelle's boss is 3 is okay because we already have 4 records. 1, 2, 3, 4 are done, right? 3 is okay, 4 is okay, 5 is okay, 5 is okay, and 10 is okay because 10 is Sniffles himself. So Sniffles is his own boss. But the sequence is important. I can't run the previous script by just changing the engine and it will run. It won't. Because it will say it's not in the right order. So let's try doing it. So let's run this first. I shouldn't see an error. There it runs, right? Try to add somebody who does not exist. So let's add Bobo. Oops. Let's add Bobo because that he or she, or I don't know, he, I think, was present in the previous table. And let's run it again. And I should have an error. Why? Because Bobo does not exist. So there it is. So referential integrity rule is wrong, right? Don't use the previous script, please. That is not in the right order. The records were not in the right order. So this script, I've changed the order of the records. And maybe the data is also different. I don't know. I had to do it, right? Because there's a rule here. And now, so I can do it. You can't refer to 12 if the 12 doesn't exist. It has not yet been added. Similarly, you can't even do this. You can't refer to 2 because 2 is still yet to be added. You can do it, right? So if you run this script, which I just did for you, I'll have problems. I'm having a problem right at the first record. Notice how it says, if you notice, it will tell you insert records at this and cannot add or update a foreign key constant DB clowns. You cannot do it because there is nobody with clown ID, boss ID 2. There is no boss. So you have to go in a certain order. That's all you have to remember. It's not easy. Like then you have to think, how am I going to insert my records? It's important now to do it in a certain order. So it's not that, oh, that's okay, it doesn't matter. It does matter. Like you have to be a little careful that I insert them in the right order. If I insert them in the right order, I'm good to go. So the constraint is now enforced, but the records have to be inserted in the right order such that a value referring should already exist. That's all you have to remember. So it's a that's all, but it's something that you have to remember. Now, oops, I'm not sure. Did I give you the answer for this one by any chance? Do you have the answer from me? No, okay, so I've picked up a wrong one then. Anyway, it doesn't matter. Hopefully the others are okay. Okay, now let's see how to answer the question. The question says, give me the name of the clown, which is easy. It's in your table. But also give me the name of the boss. The boss only has an ID, but not a name. So let's look what do I want. How will I answer this question? So I have this table in which I have 3 fields. There is the clown ID. I mean, I'm drawing all 3 fields. Then there is the clown name. And then there is the boss ID. So 1, 2, 3, 4, whatever. 10, I think, right? And Sniffles was 10. LC was 1, whatever. Can't remember the others. And then there is information. Oh, the boss of LC was LC. Sniffles was his own boss, but there were other numbers here. Whatever. Now, if I want to find the name of this, the boss, the name of the boss of LC, what will I have to do? I'll kind of draw 2 tables so that you can see why we need a self-join. Okay, so the record is picked from here. His boss ID is picked from here. And then that boss ID is again searched in the same table, kind of. And it says, oh, your name is LC. You see why I need 2 tables, 2 instances of the same table? Now, the second one picks up. He says, my boss is 2. Who is 2? You kind of look in the same table. So I kind of made a copy of the table and say, who is 2? Right? And this one says, oh, my boss is 1. Okay. Oh, your boss is 1. Who is 1? So you get the name. So the boss ID tells you who's the boss. You go to the same table to find out the name of the boss. Right? So I need 2 instances of the same table. But I don't know, I can make a copy and call it the same name. So what will I do? I'll show you how to create an instance of this table, give it another name and work with it. This is called a self-join. When a table is joined with itself to find an answer. Okay, so let's do that now. Okay, so we need the clown's name. The clown's name is coming from the field called clown, I think, right? I could be wrong. Clown ID, clown name, boss ID. Okay, so clown name. That's where it is coming from. Okay, that is where it is coming from. The boss name is also coming from a table, but there is no field called boss name. So where do I get it? That boss name is actually coming from the same table. So if you want, we'll give it an alias name just so that it's more clear. I mean, you don't have to, but right. I again need the clown name. it is still a clown name, right? The name of the boss is still a clown name. So you again have to pick up the same field. But this time you want to call it the boss name. The field is the same. It's not two, they're not two different fields. It's the same field that you're talking about. But from where? I want to pick it up from here. Oh, did I call it clowns info? Yeah, okay, I forgot my tables. Anyway, not to worry. Just a small example. And I want a copy of it from itself. I want clowns information twice. But now here is a confusion. It will say, what are you doing? Like, can you join a table with yourself? Sure, I can. Syntax wise, I'm fine. But now there is a little confusion. Ambiguity again. From where is this clown name coming? Is it coming from the first table? Is it coming from the second table? They are the same table, but they're present in both. Where is this clown name coming from? Is it coming from the first table or is it coming from the second table? And the names of the tables are the same. So how do I now remove the ambiguity? The name table is same. This is how you remove ambiguity. You can name, you can give alias names to this too. You can give alias names to your tables while you work with them. Here, so I've called my first table C1 and I've called my second table C2. So these are just two instances you're using, C1 and C2. So you're picking up the clown name from here. So from the C1 table for the first clown name, then you pick up the ID from here, go to the second table, look for the ID here and pick up the clown name from here, right? So the first clown name is coming from the C1 table, say C1 dot, like you give, but now that's what it is called. And here, this clown name is coming from which table? C2 table. There it is. But what is the condition now? What is the condition? What are you doing? You are picking up the boss ID from here and it must match the clown ID here. Right? The boss ID from the first table must match the clown ID from the second table. Write it. Just write that condition that we just said. Say where the boss ID from the first table matches the clown ID from the second table. Job done. That's an example of a self-join. A table joined with itself. And it can be done. There's logically, there's nothing wrong in it. But of course, when you start joining the table with itself, it has the same name. And if you have to qualify the fields, you need some alias names. So you give them alias names. And this technique of giving alias names to tables is not only used in self-join, it is used everywhere. Like people say, oh, the table names are too big, let me give them small names and work with it. So it's a common thing. Even when there is no ambiguity in the table names. Like the first one I said, I could have started giving names like T1, T2. It kind of becomes difficult, but then you can call it table toys or TT or something that you can remember while you're doing your queries. So here I have no option. I have to give them alias names. So I call them C1, C2. As long as if they are single words, you don't have to put them in quotes. If they have a blank in between, you have to put them in quotes. And also keep in mind that the word as is optional. You don't have to say as. You can do without as. This word is optional. You don't have to say as. You can do without as. So whenever alias names have a blank or any special character, they have to be put in quotes. When they do not have any special characters, then you can use them without quotes. Only one single word. C1 is a single word, C2 is a single word. Then I don't want to go into giving them beautiful names because I'm not showing them. It's just for me, for writing my query. But there I want to make it pretty, clown name and boss name, because that is what will be displayed as the heading. So there I choose good names that a user understands. C1, C2 is only for me. So I call them C1, C2, right? Now run this query. So LC's boss was LC and Sniffles was Sniffles, Pickles was Pickles, and then 3 and 4, Snuggles and Hobo had 1 and 1 as boss, which is LC, and it is the right table. So there is your answer, right? That's a self-join. So definitely in a self-join, tables will have to be given alias names. You can't work without them. And then you have to think which field is being drawn from which instance of the table. You can't go wrong. You have to exactly, like we have exactly to do it as I did. So the boss ID of the first table should be equal to the clown ID of the second table. Pick up the clown name from the first table, pick up the clown name from the second.
There's only one table.
There is only one table physically. Physically, there is only one table, but while the query is being done, it makes a copy of it and uses it. Oh, somebody else getting an error? Did you qualify your variables all properly, the fields that you are selecting? C1 clown name, C2 clown name, C1 boss ID, C2 clown ID. Okay, what is the error? Ambiguity? Oh, the problem is not here. The problem is here. You can't add Bobo. Yeah, the problem is here. Remove Bobo. I was only showing you that you can't add it. I have removed it now. Maybe that's the same with you, Amanda. We removed it. Comment it out or whatever. We can't add.
When I'm using InnoDB, it gives me error. But when I'm using MySQL, it doesn't give me error.
And it works?
Yeah.
And is this the one that you're working with InnoDB, the one that you're working with InnoDB? On this one.
Yeah.
And you said it,
MySQL.
you said it with MySQL. What about the first one?
Like for the previous.
Did you add Bobo to it and it adds it?
No, I didn't have
Either
That-
comment out Bobo or make his ID.
Yeah, try adding Bobo in MySQL. And the sequence is
Commented about it.
whatever, like, have no idea how Dream Host behaves, and that's why it's important that you maybe at this point you see. It's varying when you're so either the Dream Host has an older version or something. God knows, so it shouldn't, right? It is a server,
There's a poll
and it lets you add Bobo 12. Oh, but that's with ISAM, right? With ISAM you can add. ISAM will not give you a problem. ISAM you can add. It doesn't even enforce it. See, it's not even enforcing it. And what happens when you do InnoDB? So my ISAM will not enforce sequence referential integrity. So yours runs. It will. Ours was also running well, but the ISAM one was running. What happens with InnoDB?
You're still screwed up.
Lot of errors. Okay, so let's start with the first.
Yeah,
one.
don't worry. If you comment
Cannot add foreign key.
saying C1 clown name is not.
Okay, I can tell you something. Let me tell you it will do. Take your 29 line and comment it and do the alter statement. Just comment that one. Okay, and then no, not this one. We'll have to put a semicolon, remove that comma. And alter it. Remove these comments. So I'm doing the foreign key, but I'm doing it afterwards. Okay. Okay, now try it.
L. I don't know how I put an L in. Oh, because maybe it's right. Should be clown.
GG though. GG.
That's okay. That doesn't
Yeah,
matter.
it was CL.
You did it, right? Tables, names don't matter.
Oh, instead of one.
Okay, now we have another
Somehow, I don't
alter
know how,
table
but I
format. Cannot add foreign request. Okay, it's not even allowing you to do it. I don't have a solution then. Because it's you're working on the DreamHost and I can't do nothing about it. We can't. I have no clue. DreamHost somehow I don't know why it is doing it. I have no idea. The InnoDB for Arch is not working. It says you can't add a foreign key. So what I made her do is I removed the foreign key. Okay, try something else then, Arch. Take that alter statements from here and add them after you've inserted the data. But you'll have to be careful now. You're basically inserting first and creating the rule afterwards. So remove your Bobo 12 anyway. Logically, it's not right. So now try to remove that error. But you see, that's playing around with it. That's making too many adjustments. And then it's simple. So put your alter statement. Yeah, remove no, semicolon, and then your alter statement should come here before the select. That means after now it's okay. Now let's try. No, it doesn't. It cannot add a foreign. You cannot add it. It says. I have no clue. What is happening on your DreamHost? I have no clue. This is how it should work because that's the right way of doing it. Then again, some set command. I have no clue. I don't know. I can't help you. See now here comes like you have to know the server's configuration. But if you don't know the server's configuration, what else can you do? I altered it afterwards. It wouldn't let me do it. It just doesn't let me add. It's not allowing you to work with foreign keys in the same table at all.
And I don't know why shouldn't be. It's an InnoDB, we've already said engine is InnoDB. It didn't allow it there, I made you do alter isn't working, I made you change the alter, I don't know why it is not working. Unless you've done something else different from my script, which I don't know. What changes did you make? Oh, you have the result.
Yeah, the result is the same, but I'm just talking about this error. Why?
Yeah, if the error is there, how will it do it then? Oh, that means it's just not making it a reference key, that's all it is doing. Yeah, it's not doing that constraint. Yeah, so now see, I'll tell you what it is not allowing you to do. Okay, go back to your script. And add that bobo to elbow. It will allow you to add bobo to elbows. Add another record, and you shouldn't be able to. Put a comma. And then, yeah, and here, there. You can add this to where it shouldn't, because we said this is a foreign key, but it will.
I do.
See? I would highly recommend that you do it on your own laptop now, because things like this, you'll have to work around. And I mean, then we have to look for ways, right? And I don't want to look for solutions just because you're working on DreamHost, right? So now just because if you see it here, I've written an alter statement afterwards. So if you don't want to put this right here, you can always alter it afterwards, just so that you know it can be altered afterwards also. So how do I alter it? I say add foreign key. Remember we did add primary key? You can also add foreign keys afterwards. So this is working right here and it's perfectly fine. But if you don't put it here, you can also always alter your table afterwards. You can always add a foreign key afterwards also. So that was just to show you it can be done. Alter can be done afterwards also, so that you know it can be done, because primary keys can be added afterwards. Foreign keys can also be added afterwards. But with you, I really have no clue. I mean, so we tried this. I removed it from here, added it afterwards, wouldn't work. Added it afterwards, wouldn't work. It's just not behaving as it should behave. So Ashpreet, I would recommend for you at least, so that you don't waste time in all this extra things, install WAMP or XAMPP. Or you have Windows machine, XAMPP or WAMP, whatever you like on your machine. You should. It's I mean, for the next of the 5 weeks, that's all we will be doing. And if it doesn't behave itself, then you're stuck. You know what I mean? Yeah. It's up to you. I mean, I'm not forcing you, but definitely you will be seeing self joins and foreign keys in your exams and in your assignments, right? So I leave it to you, because this is just doing stuff that I don't have an answer to. Maybe Brian will have an answer. He's not here today. Maybe he can figure it out. But yeah, so I don't know. You'll have to install it yourself. Okay, do it afterwards if you like. You'll not need it for the rest of the class today, so you're okay. But keep in mind, somehow foreign keys are not being enforced in your scripts on your server, which is so odd. I don't know why. I don't know. I can sit with you for some time and kind of test it out, but I don't have an answer otherwise. Okay, so there it is. So that's a self join. So self join just makes a copy of its own table only for the purpose of doing it, and of course it's not a physical table. Physically it's only existing once. Okay, the create table creates it, otherwise nothing else creates a table. Okay, so let's do this, and I'll put this on Blackboard. Now open up. Let's go to, what do we have? Beer is a big one. Contacts. Okay, open up contacts then. That's not a big one. Okay, let's open up that one. Again, it's joins and all that. All I'm doing is joins now. However, whatever I can do. Okay. My contacts jobs, not with the 2, just without the 2. Okay. So now this is a database in which I'm keeping information about my contacts, just some people, right? Notice what do they have? They have a contact ID, a last name, a first name, a phone number, email, a gender, a birthday, and a zip. So birthdays are not very useful in my even gender I'm not using, but again I picked it up, so it's fine. But zip is a kind of an odd value to put with a contact, but this tells you where the person lives. So if the person is looking for a job or whatever, then he's looking for something near him or something, that is where zip comes handy. Okay, so zip is just where the person lives, zip code. Okay, that's what the zip is. The rest are all okay for a contact, for a person. Every person has an ID. I mean, because there is nothing else we could think of. It is an auto increment
primary key. Every person has a last name, a first name, phone, emails, gender, and birthdays. So zip is the odd person, the odd field out, but just for this purpose, I need it for my code. Okay, so that's my first table. Information about some contacts. Okay, and normal table, nothing big in it. It is in the third normal form. It has a primary key, first normal form. All other fields are completely, and the primary key is a single field. So there is no kind of, it is automatically in the second normal form. What about third normal form? Do you see any non-transitive relation, indirect? No, everything is directly dependent upon the ID. First name, directly dependent. Last name, directly dependent. So is phone, so is email, so is gender, so is birthday, so is zip. Everything is connected to contact ID. There is no indirect relationship. So it's also in the third normal form, right? Let's go to the next table. I've inserted some data into the table. I have not taken any time in changing anything. I just took it from somewhere and I just copied it. So the field list is here, which is good enough. You are aware of putting a field list because I haven't put the numbers 1, 2, 3, 4. So you have to give a field list because you have another field called ID. So I have to have my field list. So there is the field list, doesn't have ID, contact ID, because remember it is auto increment and it will automatically be inserted from 1, 2, 3, 4, 5, 6, 7, 8 till 12. Okay, let's go to the next one. This table is telling you about the jobs that the contact is doing right now. So what is the contact doing? So the contact ID again, the title, what title he has, like computer programmer, database programmer, whatever, chef, baker, system analyst, whatever. So that's the title. The salary the person is taking. Now you could, if you like, make this not null because, I mean, if a person is working, he needs to have a salary, right? So you could make it not null. It's up to you. But I removed it because I will try to show you something with a person who's unemployed or a person who's a student and they don't have any salaries or hire date, start date. So I've left them not null for now. Right now, I don't have anything that's null, but I will, if I show you an example, I wanted to put that extra record, and that extra record, if you kind of notice, this person doesn't have, because he's a student, we are saying he does, it's student just says he doesn't have a job and doesn't have a salary. But logically, if you have a job, you will have a not null here and you will have a not null here. You should, right? So right now, since there is nothing which stops me from doing it, I will. And when I don't require to, I can remove it. Logically, these two fields should be not null. Okay. For now, I'm okay. Everything in my data is okay. Now look at the constraint. There is one, so there is a primary key. Your contact ID is also the primary key of this table. You'll say, oh, the same contact ID? Yep, why not? It uniquely identifies every record. It's not an auto increment key field. Please remember that. It's just an int field that is drawing its value. It is referencing the contact ID from the my contacts table. So it is a primary key, but it is not an auto increment primary key. It is referencing its value from the my contacts table. I'm only keeping information about my contacts. You cannot enter the database without having a record in the my contacts. So all contacts are in my contacts. And then the ones that have a job are in the job current also. Okay. So that's the information on job current. So person number 1, whoever that is a technical writer, earns that much, and his start or is, I don't even know who one was, but whoever it was, Gillian Anderson, has that start date. So here are some records, right? Normal records. The ID of the contact, the title of the contact, the salary he or she is taking, and the start date of the contact, right? That's job current. You can ignore the comments one right now anyway. Okay, now comes the third table. Now there is a table called job desired. Now job desired means, okay, I'm working as a chef, but I really want to be a system programmer. You know, so people can desire a job. You'll say, why are we keeping that information? Because if people need some jobs and a job listing comes out, I can do a match. And I can say, oh, your job is available. Same thing like your co-ops, right? Like, yeah, there are listings. Rita sends out listings, they're all on the web. Right now, you can only apply to them if you kind of satisfy some conditions. You should have passed your semester 1, your semester 2, or intro to Java, something like that. So that's job desired. It's just saying this is what I want to be. I don't have, or I may have a job, but I'm not in the right job. So job desired says this is what I want. Okay, doesn't mean you don't have a job. You could, and you still would like to change it. So in the job desired, again, I have a contact ID, which is again referencing its value from the contact ID in the table. And This person says, this is what I would like to be. I want to be a computer programmer. That's the job I desire. This is the minimum salary that I'm ready to take. And this is, it should not be called high, it should just be called salary, but this is what I'm expecting. So I'm ready to go down to this low, but this is my expectation. Salary high means this is my expectation. So both figures are there. Why? Because again, the job may be available. It is the job that you want, but it is not giving the salary that you want. So you are saying, okay, this is what I'm okay. This is what I'm expecting, but I'm ready to go down a little. So salary low is that value. The salary high should, I think, be called something else. I think we should call it salary expected. The high is kind of saying, oh, this is still where I can go. Nobody says this is still where I can go. Nobody says that's my upper limit, right? So high should be basically expected. And then how many years of experience do you have? How many years of experience, which is a tiny int unsigned. Okay, so that's what it is. That's what this table is, the job desired table. So you have a contacts table, you have a job desired table, you have a job current table, and then you have a table which is called job listings. It's called job listings, right? The job listing says these are the jobs available in the market. Nothing to do with the contacts at all. It's just the job table. Each job has a job ID, has a title, the salary, and the zip. So this zip is kind of important when people say, oh, I'm looking for a job in this area. Okay, so there is a zip here also. Where is this job available? So that's a job listing table. It has no connection with any of the other tables. But if I need to make a connection, I'll have to join them. So people want jobs. Here are the job listings. Is it available? Then I'll have to join those tables. Okay, so the first thing you will do is you will run the script. You will run the script and you will create an ERD before we start answering questions. Okay, so run the script. I think you'll be able to run this one. Oh, but there is a foreign key. I don't know. Try it. Oh, your error. Where? Years experience at line 1. You have error in your SQL syntax. Was it highlighted by any chance? Okay, it was highlighted. It was just highlighted. Here is your table. Tables, I should say, right? That's your contacts. Okay, information about contacts, information about people who have currently a job, information about people who want to change their job or are looking for a job. So see, 2 people want to be computer programmers, one a chef, one a baker, one a sales manager. Just so that you can remember, because we'll start using them quickly, right? And here are the jobs available in the market. So there is a baker job. So somebody was looking for a baker. There is no computer programmer job. There is a clown job. There is a lawyer job. Oh, there it is. There are programmers jobs. There is a programmer job also, right? So here is your job listings. Once you have this, please create your ERD. So go to database, reverse engineer. Oh, what was it called? What was the database called? Jobs. Okay, thank you. So let's go to database, reverse engineer, correct connection, and jobs J. MNOPQ. There it is. Select your schema. Schema means the database. Okay, schema means database. 8. Oh, the other one was also selected. Oops, I'm saying 8. There were only 4. Of course, there were only 4. Okay, so let's try it again. You don't have to if you didn't make that silly mistake. I didn't uncheck my previous one. Database, reverse engineer. So there's a forward one also. You notice that, okay? There's a forward engineering also. You create your diagrams and it will create your script for you. Okay, so I have these. This one has to be unchecked and the jobs one has to be checked. There it is. It's a checkbox. So there it is. So that's your job current. I would kind of keep the contacts in between because contacts is connected to all the tables. Try to put them so that you can read them easily, right? So the job table is connected. The my contacts is connected to job current also. And it is, see here it is, the white one without the blue. Years of experience was not null. Yeah, that field was null. Yeah, so it's not null and null. Okay, for your information, it's null and not null. Blue means it's not null and white means it's null. Red, I haven't seen one, but did you see it somewhere? The red one? Just the meaning was there?
Online, there was one that, there was a photograph.
Oh, and it had a red one?
That were complicated.
Oops, okay. Maybe it will come sometime then. Yeah, I haven't seen one in this course, so, and I've never taught the advanced one, so could be, yeah. I don't know, maybe something to do with the connected to a stored procedure or something, I don't know. Right, so there it is. Blue means it is not null field. White means it can be null. Okay, and the rest you know. Names of tables, primary keys, foreign keys, relationship diagrams, and you can always edit a relationship, though you won't usually, but you can always go right click and you can edit it. So what it is saying, what happens in edit, you can always say so you can always change it here if you want, right? Anyway, I mean, we don't want to have to, but we could. There it is. Our ERD is ready. Now let's start answering our questions. Okay. So keep ERD handy because it will be required. So again, in this example, again, I'm going to introduce you to a few more things as if the previous was not enough. But anyway, so that again, if you need it, you have them. Okay, we'll start with the first one. There is a union operator, like all your other operator. I don't know whether I should call it it's not a function, so I can only call it operator. I don't know. But there is this verb called union that you can use in MySQL, whose job is to unite values from all the tables on a particular field. So you want to just give a complete list. For example, if I was say, give me all titles that are in job current and in job listings and in job desired. So of course, when you unite something, it is the same field. You can't say, oh, unite the name from here with the age from here with the years of experience. Doesn't make sense at all. So when you unite something, when you join something like a field, I'm talking about union, you always unite elements of the same kind and for us also of the same nature, like contact ID or title or salary or something. That's the union verb. There are two of them. One is called union, which removes the duplicates, and what is called union all, which does not. How is it used? It's like this. Example, select. So you can say select the title, because you have to pick up a field that is common in all the tables from which you're uniting. Not only by name, not by name necessarily, by nature. It could be called title in one, it could be called your title in the other, it could be called my title in the third, but it is of the same nature. It's the same related field. Okay, so select title from your first table. So you know what? I have the table names. That way it is easy. Do I have the table names? Oh. Yeah, I have the table names. So that way you can just copy mine. Okay, so I'm going to go one at a time. So there is a table job current. Oh, there they are. We can see them right there, at least in this one. That's one table. From this union. So we'll use union first. It will remove the duplicate, and union all also I'll show you. And then kind of copy it and then change the table names. From the second table, from the third table. Oops. Change the names then, please. That's union. You use the union and you do it. So your job current is your first one. Job desired is your second one. I mean, the sequence is not important because it's just collecting it from each of the tables. That's union. And we'll look at the result. So all titles from the first table, the second table, and the third table. And if you want repetitions, all you go is union all. So let me show you union all first. You will see repetitions. There are repetitions. Remember, job listing had a computer programmer and job desired also had it. So union all will give you repetitions. Okay, let's try it. Let's run it. So all titles will come up. There it is. And you see repetitions. You see computer programmer being repeated for sure. I see technical writer. Web designer, not technical writer, web designer. There they are. That's union. It says pick up all the values from the first table, from the second table, and from the third table. And nothing stops you if you want to order them. I mean, the other things remain the same. Oops, there. You can order it if you like. Right? If you remove the all, you will see duplicates will not occur. I mean, you don't have to remove all the alls, but why would you like to put some unique in there? Only every one occurs once. That's the difference between union and union all. So it is available. And can you relate it? What is union? What is it? It's an inner join. You're just selecting the title field on inner join, and what's the condition? Title should be equal. That's what you're doing. But you have a verb for it. You have a union. So if you wanted to join 1, 2 or 3 tables, and you want to say that pick up the title field, I mean, it's not even comparing a condition. It's just picking it up. If you say like it's just picking up a title. It's not an inner join. It's a cross join. You're just picking up the title from the cross join. That's all you're doing. Right? I mean, not that. Logically think about it. What does a cross? No, not even that. No, it's no relation to inner join at all. Because when you cross join, you have titles at 3 places. This is doing this way. All titles, and all titles. Okay, I don't see anything. We can't. Union is just a union. Picks up all the values from a column, from one table, from the other table, from the third, whatever you say. Now, just I've never done it. I've mentioned it. If you wanted to, what you see here is only on the screen. If you wanted to create a table and put these values in that table, you can do it right here. Do it with me. Say create a table. Create a table, let's call it jobs or job titles. Table job titles, whatever you would like to call it. Right? And you're creating this table and put an as there. Like you're basically saying this is what it will have. So a table can be created on the go, right? The table will be called table job titles. It will have only one field called title, and it will have, and the values in that field will all that you see here. You can create a table on the go like this, right? So the table is called job titles, and it will have all this. So we haven't never created tables like this, but as I said, all you see is only display on the screen. But you can always put your results in the table. You'll say, how will I know it was created? Do you remember that command of show tables? Show all your tables. Instead of 4 tables, you will see 5 tables now. The new table has also been created. It is also a part of your database now. Do you notice a new table? No, we don't. Yes, we do. There it is. Job titles. So this table has been physically created for you. Like it's there, it's in your database. So tables can be created on the go. There is more to it, but we'll do it. But this was just introducing you. I don't know if I'll do it, but I mean, if it comes, at least you know. All I did was I added a create table command. And I said as. I don't even think as is optional here also. I don't have a syntax error. Even as is optional here too. There it is, it still gets created. So the word as is again optional for your information. It is optional in the alias names also. It is optional here also. The word as itself. But there is a table. So by default, you'll say, what are the fields in this table? What goes into this table? What are their types? Automatically, what is it doing? It's picking up the title from the first, title from the second, title from the third. It only has one field. What is it called? You could give it a different name if you like, but what is it called? Title. And what is its type? Varchar, whatever it was in the tables. So if you want to describe the table, if you want to describe your table, you will see. You can describe this table. Take your table and describe it. So that you know. So describe your table. Let's see what happens. Run it again. And go to the second last input. There it is. It has one field called title. The varchar is 30. Null is allowed. Now here we'll have to change that now. So it has automatically allowed null, whereas those fields are not null in the other tables. But that's what it has said. Yes, null is allowed. The key doesn't, it's not a key, and then default is null, and the extra, there's no extra. But it does create a table. So tables can be created, though why should we when we only have to see the result? But that gives you an idea. Okay, let's go to the next one. Intersect. Intersect says I'm going in normal mathematical intersect. Find the common ones. So if I want to find what is common, what is the common title between listings and say desired, I can use the intersect one. Unfortunately, it is not available in MySQL. So what should I do? How do I do it? We have to use some join that we did, right? So union is available. I was able to use it. Intersect is not available. So let's do a join. Produce the job titles that are, common in the 2 tables, TBL job listings and TBL job desired. What should you do? Select, do your selection. Select your title. Now, since title is in both tables, I'll have to make it, I'll have to qualify it from, there are two tables, job listings, Control C, and I'll start using commas. Of course, you can use inner join if you want, and job desired. Now, because these table names are long or whatever, for whatever reason, I'm start calling them names. Job listings is JL. And again, you don't have to give it in caps or whatever, it's up to you. And job desired, I'm calling JD. Okay, so now what are we trying to do? Job titles that are common. Come here and look at your ERD diagrams. So I want job titles that are common in the desired one and in the listing ones. You'll see these two tables are not even related. Like they're not even related. So that's okay. That doesn't mean I can join them. I mean, the joining condition, there may be no joining condition, but there they are. But they have a common field called title. So I'm trying to say they should be in job desired also, and they should be in the other one also. So it is not available. We'll do it ourselves. So let's do it. Oh, let's go back. Oh, sorry. Let's go back. Oh, you know what? It's 2B. This answer is for 2B. So I've given 2A, but it is not available in MySQL. So therefore it is, there it is. Okay, now let's complete this, right? So I'm doing the same thing that an intersect does, except that it's not available. Okay, now where is your where condition? So those titles which are common in both. So definitely if they're common in both, their values must match, right? And since it is a varchar field, I've just trimmed them before I've matched them. Remember your trim function? So that it removes any extra blanks on either side. So I've trimmed them before I have used them. So JL dot something, and that dot something is title, and JD dot something, and that dot something is title. There it is. Instead of comma, you could have used an inner join, the word inner join. Depends on you. It's up to you. I've gone with the comma. Let's see what happens. Common jobs. So it's basically saying if you find a partner there, spit it out. If you find a partner there, spit it out. That's all it is saying, right? Pick it up and run it and see what the result is. Common titles in both tables. Oh, title field spelling. Title in field is this ambiguity. Oh, there it is. Which title from which table? I mean, they are present in both tables. You can pick up whatever you like. Really doesn't matter. They both have title. Because you're matching on equality, they will be the same value, right? So now run it. And notice the output. I have a baker. There was somebody who wanted to be a baker, and it was also available in the job listings. But in job desired, 2 people wanted to be computer programmer. So they find a match. Now, I don't want to see computer programmer twice. You'll say, oh, I want to, because that will tell me 2 people want that job. That's good. That's fine too. But if you want to remove it, all you're interested in seeing what is desired and what is available. So it depends. What will you do? Do you remember that verb? Remove duplicates. So you have an intersect and you have an intersect all. No, we have both. So again, depending upon whether you want to see duplicates or you don't want to see duplicates, you will use distinct or not or without distinct. So distinct says there will be no duplicates. So it's like your intersect. And if you don't put distinct, it will show you the copies also. So that's like your intersect all, whatever you want to choose, right? So as I said, you can replace the comma by the inner join if you like. I've used comma, you can replace it with inner. And you know what? I can show you another one actually. That's also neat. Because I haven't done it. This gives me a chance of showing you whatever I want to, and then you kind of so with the inner join word, so this is one for sure. You've already done this. With the inner join, there is another option you can use instead of where. I'll show you that option. It's called using. And using does the same job that the where equality is doing, so that you know. There what it is saying. It is saying pick up the title again. Oh, distinct, please. Yeah, I have. So it depends whether you want distinct or not. That's not important. So distinct is just all or without all. So what I want is I want to pick up the titles from the job listing table and the job desired table using the title field. It will automatically pick up the title field from both, look for equality and give you the result. So there is using. Interesting, right? It's like it has replaced the on or the where, because both are possible with inner join. It has replaced the on and where, the condition has gone and you've used using. You could have used a natural join also for your information. You can, because we are talking about the same field for equality. Try that too. So, I mean, there are different ways of answering the same query. Okay. So instead of inner join, say natural join. And remove the E using at all. Remember, we don't need anything in the natural join. It will just pick it up. All 4 answers should be the same. All 4 should work the same way. Computer programmer and baker. So there are 4 ways of doing it. So we don't have an intersect. We don't have an intersect or an intersect all, but we have 4 ways of doing the same thing. All 4 answers are same. There you are. 4 ways of doing the same thing. So 3 of them are using inner join, but 1 is using with the comma, 1 with the word inner join, 1 with the using. And again, remember, instead of where, you could have used on here. You know that. So there are actually 5 ways. You can do the same thing using on. So my aim will be to show you everything, and then you can choose your preference in the real world. In an exam, you cannot. This will also work. On can replace the where. Same answer. You will have the same answer. There it is, right? So that's intersect. But because it is not available, I had to use this. Let's look at the third one now. The third one says except, like a minus, like the left outer joins you did. We don't have it again. But there is again an except and a minus. They are both not available in MySQL. What does it do? What we did with left outer join. Something that is available in one, but not the other. So this it would be so easy if we had it. MySQL doesn't have it. So how will you implement it? You will implement it using a left or a right outer join. So what is the question? The question says a list of job titles that are in the job desired, but not in the job listings. So quite clear. It says find a match, but if you don't find it, then let me know. So they're available in the job desired, but they are not in the job listing. So you're looking for a job that you want. It's your desired job, but it is not available in the listing. So think about it, how to do it. So as soon as you kind of talk it in terms of except or difference, it is an outer join. Though again, I can show you that it can be done in more than one ways. So I want a job and it is not there. Not there means I couldn't find a partner there, right? So let's write it. Okay, do it with me. This will not end for the next 4 weeks, guys. So bear with me, okay? So what are we trying to do? We are trying now to find a job in the job desired and not in the listings. Okay, so select title. They don't say anything, so I mean, nothing is said, so I'll just do a title. And we'll have to be careful again. You know what? It is just a little easy of kind of going this way. I'm copying it here. Okay. So job desired comes on the left and job or you can use a right outer join. How does it matter? Of course, it can be done using a left outer join also. I just stuck to right because this table was on the right. Okay, there we are. Right? So jobs that are available in the desired, but not in the other. So your condition, remember this is an outer join. You have to use an on. You can't use a where. And your on condition is, so JL dot something is equal to JD dot something. And that dot something is the title. And that something is the title. We haven't yet finished because this will just give a join. But we want to pick up those jobs that are here, but not there. So where? So you can always go in steps. You don't have to do everything together. You try to kind of go in steps like I did in the previous one. First, see what the answer is with a star. then see what the values are, then see which records you don't want, and then remove them. Okay. What are we doing? Okay, so where, and then now the where says you can pick up the title from wherever you want. So the first table had list job desired, and the second table has job listings. Okay, so job listings is something that is available. Job ID. Remember, it had a job ID. I'm just thinking of the fields in the other table. Definitely job ID is available in job listings. I pick up that field, and that field not equal, keep in mind, is with null. There it is. Same thing that we did in the previous one. And of course, you can do it using a left outer join. I better show it to you because, and use a left here. As soon as you use a left, your tables change. This one goes here, and this one comes here. And it will the same job. Make sense? Same thing. So wherever you see this except this minus or something that you're trying to find out that is in one and not in the other, you will always need a left outer join. Oh, sorry, an outer join. I'm not saying left or right, both are same. I'll look up. There has to be some difference when they created two of them, right? Logically, why would they create two? I don't know why would they, because all that is different is the sequence of the table, the position of the tables. I'll still look it up. I've always thought it's useless, but maybe there is something that I don't know about. To me, there is no difference at all, except you're keeping the left. When you say left, the table should be on the left. When you're saying right, the table should be on the right. And maybe there is something to do with the search algorithm that is different. I'm not sure. Yes.
So Baker programmer should be coming up?
Sorry?
Baker and computer.
What do you think? Here, but no, here, but not there.
So
Baker and the programmer had something in the listings. Now, leaving Baker and programmer, anything else should come. It's not showing anything? Okay, now let's see. What have I missed? Think about it. Distinct? No, not to do with distinct at all. Route origin. So let's see. The only possibility when nothing is coming up is you're not logically doing it right. So it is saying jobs that are desired and not in the listings. Now, who is the bigger and who's the smaller table? Listing has everything. Think about it. Listing has, okay, so see what is happening. Job desired, this, and this. So let's go. I thought it was right. But again, if there is no answer, then there definitely something is wrong. Let me run it and see. Yep, no answer. Of course, you're right. You're quicker than I am. Let's go back to see the tables then. Okay, listings has a huge table. Now we are saying the question says, people desire this job, but it is not in the listing. So computer programmer found something. Computer programmer found something. Sales manager also found, no, sales manager does not find anything. So if it does not find a partner, its correspondings will be null. And I want that to spit. Yeah, so sales manager and chef should come up, right? Left outer join. Try to join every record here and say hello there. Why is it not working? Job desired on the left. Find a partner. Find a partner. If you can't find a partner, give null. Something in our condition? I don't think so. Logically, it looks right. I don't see a problem, but something definitely, right? Oh, no. Oh, wait. Wait. Oh, do you see what the problem is? I see it. I'm saying show me the title from JL, the L table, whereas the L tables are nulls there. You see, I mean, which table to pick up, you have to be careful about that. I thought, oh, it's title in both. See, what am I showing? The title from the JL table. Now, if a partner was not found, then the title is null. The title is also null. So that's what, there it is, JD. There it is. There's the problem. So logically, it looked okay. And I'm saying, what is wrong? There it is. And there, it should work now. A silly mistake, but it's important. Like, why? Titles are present in both tables, so I didn't bother. I said, okay, they're present in both tables, doesn't matter from where I pick up. But look what I'm saying. I'm getting some fields from the first table and I'm getting some fields from the second table. Now I only want to pick up those records in which the second table is kind of null everywhere. So if it is null, how will I get the title from there? The title will also be null. So I have to pick up the title from the first table. And now it should work. Does it work?
Yeah.
Okay. Yeah, so we had that sales manager and chef because programmers and bakers already were in the listings. Okay, so again, okay, good, it came up because now whenever you see something, you will be careful and so will I be. I didn't even think about it. Now, just so that you know, before I let you go, in last 5 minutes, all I'm doing is I can do it another way, which is a sub-query for your information. So we will be doing sub-queries. It's called a sub-query, a query inside a query. So what do you want to do? Now it doesn't really matter, but anyway. So you want to pick up. Okay, now let's see. Okay. Okay, you want to pick up all those titles. Now the names, the qualification is not important because I'm only dealing with one table. I want to pick up all those titles from the listing tables where I can use both not in and in, where this title is not in. And look at my not in. What am I trying to create with the other one? Subquery means a query inside a query. Okay, that's all it means. And this is the subquery. Select title from job desired. A subquery works this way. A subquery, the select title from job desired will be first done. So it will have all the titles that are in job desired. Baker and computer programmer and chef and whatever it was, sales manager. So you get that list, right? Once you have that list, then from the bigger table, from the listings table, you're saying, tell me those that are available here and not here. So you're saying, pick up, not here, not here, not here. Make sense? Is the logic right? Or is it the opposite thing? All these are desired. Yep, should work. Oh, no. Think. Let me think. Is it the opposite? What do I have to do? I have to find all jobs that are desired, but not in. My mistake. All jobs that are desired. All jobs that are desired. Yeah, right? All jobs that are desired, but not in the listings. Yeah. Yeah, there it is. All jobs that are desired, but not in the listings. But it is still a subquery, but of course this is making more sense. Some people like subqueries because it's more easy to understand. But again, there is a whole question of efficiency in code. Maybe not in small databases which have 10 records, but in databases where there are trillions of records and you're trying to join tables and so on, there is always a question of efficiency. So if you go and Google and try to find out a little about queries versus joins, you will have a little more knowledge about it, and maybe will make sense when I do it and say, oh, this will be quicker and this is a better way of doing it. Oh, an inner join is better than this left join. So I'll give you, when I do queries, I'll give you all solutions. And then we'll discuss why is this better than this. Because this one is saying all that are in job desired, but not in this. So there is no ambiguity. This title is coming from here. This title belongs here. And this one is here. But this is called a subquery, a query inside a query. But notice the outer query cannot complete itself till the inner completes itself. So the inner one happens first, comes a whole list of all the jobs, all the titles in the listings. And then this table says, are you in there? No, spit out. Are you in there? No, spit out. Are you in there? Don't spit out. So if you do this, you should have the same answer. And the answer is sales manager and chef. There it is. So that's a subquery. It's more, I know it is a little easier to understand, but it is necessarily not efficient than a left-out join. Yes?
So it looks like the subquery goes in the same format as left-outer join.
Let's think about it. Yes, because you're trying to say it's here, but not here. Yeah. If I wanted to use an in, will it make sense? No, it won't. Oh, you know what? Yeah, let's see. If I want to not in, I change my not in to in. So I say pick up all those jobs No, this is the only way I can do this one. Yep, you're right. It's like a left outer join, but it doesn't work, like it doesn't take the same time as in terms of efficiency and so on, it will be different. Okay. The order in which it goes is the same. You're right. You use a not in because you're saying which are here but not in here. What is a left outer join? You're saying they're here but not in here. I mean, it's not always here and not in here. We choose out of them by saying equal to is null, but otherwise here and not here. Yep, same kind of stuff. But that's not a left outer join. Don't kind of think, oh, left outer join will always say what's here and not here. It just tries to combine, and then from there you take out what's here by and not here by using is null. Okay, and if you want to say is here and is here, pick up the records which are not null. So it depends on you. But that's the way of doing it. But that's not its answer. We pick up by using is null or is not null. Okay, but yes, it combines a table with another table trying to find partners. If it finds a partner, combines. If it doesn't find a partner, puts null in the values. So if you're looking for partners, you will say is not null. If you're not looking for partners, you will say is, right? That takes care of what I want to do today. So I'll put these 4, 1, 2, 3, 4 on your blackboard, and we'll come back, and the rest two we'll do next week. The clowns and the sports. Oh, there was not clowns, beers and the beer script and there are more. So don't worry, it will go on. And now in the meantime, I'll create an assignment for you. Okay, now that you know a little join, now you know it. Till last week it was just normalization, but now you've seen it. You've seen everything. You've seen a left, a right, a natural, an inner, a subquery also, though it's really, really small, but a subquery. So I try to stick to joins, and then a union and minus and except we have to do it ourselves. So I'll try to now create a assignment. Not create, I'll get an assignment. What else? Okay, this will go on Blackboard. Okay, guys, we are done for today. Thanks for your patience.